Welcome to Deep Sleep Studios, a place to calmly explore the most astonishing parts of our universe while helping you drift off to sleep. This is a place for gentle attention and unhurried curiosity, and also for letting go. Tonight, we'll take a gentle space cruise through our solar system. We'll move slowly, like a quiet ship that has all the time in the world. In this calm journey through space, we'll begin near the Sun, where light is born, and then drift outward, world by world. We'll pass Mercury, a small cratered sphere of stone and shadow. We'll float by Venus, wrapped in bright cloud. We'll glance at Earth from a comfortable distance, with the Moon gliding nearby in patient orbit. We'll linger over Mars and its wide, rust-colored silence, then ease through the asteroid belt where small worlds turn in the dark. Farther out, we'll arrive at Jupiter with its slow bands of cloud and its drifting moons, and then Saturn with its bright, delicate rings and its hazy, distant companions. After that, we'll continue into thinner sunlight with Uranus, pale and tilted, and Neptune, deep blue and far away, before drifting into the Kuiper belt, where icy travelers circle in long, quiet loops at the edge of the sun's reach. If you're enjoying Deep Sleep Studios, you can like the video and subscribe for more gentle journeys like this. And if you'd like, leave a comment with where you're listening from and what time it is. It's comforting to know who else is out there, quietly drifting through the night. There is nothing here that needs your effort, nothing to solve, nothing to hold tightly. If you're still awake, that's perfectly all right. We're simply traveling, observing, and letting the details pass by like slow clouds. Imagine our cruise as a steady glide, smooth and simple, with the solar system laid out like a quiet gallery of light and stone, ice and dust, shadow and motion. Space does not rush. It turns and returns. It repeats. It circles. It offers the comfort of rhythms so large and so patient that they make our own clocks feel small and perhaps a little less insistent. We begin close to the Sun, not as a place to approach dramatically, but as a presence to understand gently. The Sun is the center of this local family, a warm anchor that holds the planets to their paths with the calm insistence of gravity. From Earth, we think of it as a bright disk that rises and sets, but here, near the Sun, it becomes something more textured and alive. Its surface is not a solid ground, but a luminous layer of hot gas, glowing with a steady intensity. If you could watch that glowing surface for a while, you would notice that it is always in motion. Not fast in the way a flame flickers, but restless in a more gradual sense, like a sea made of light. Bright regions swell and soften. Darker patches appear and fade. The Sun is made of gases so hot that they behave in complex, flowing patterns, carrying energy outward. Deep within, energy is born and begins a long journey toward the surface. By the time it finally escapes as sunlight, it has traveled through layers of churning matter, guided by pressure and heat, by slow convection, by the patient work of physics. The sunlight that reaches us feels immediate, but it comes from processes that take time and follow rules that never hurry. In the Sun's outer layers, hot material rises, cools slightly, and sinks again. This constant cycling creates a fine mottling across the surface, a granular pattern that from afar looks smooth and even, but up close would feel like an endless field of softly boiling brightness. Above the visible surface, the Sun's atmosphere becomes more tenuous, more transparent, and more mysterious. It extends outward in layers, thinning as it goes, fading into a vast halo. During an eclipse, from far away and safely filtered, this outer atmosphere can be seen as a delicate crown of light. It is there, in that extended region, that streams of charged particles can be set free, drifting outward to become the solar wind. The solar wind is not a loud gust, not a roar or a blast, but a continual outflow, subtle and persistent, like a gentle exhale that never fully stops. It carries the sun's influence far beyond the planets, shaping an invisible bubble in space. Within that bubble, magnetic fields twist and stretch, guiding tiny particles along spiraling routes. Sometimes those particles meet a planet with a magnetic shield, and they are gently funneled toward polar skies, where they can paint the upper air with slow curtains of light. Here, close to the sun, the light is intense and shadows are sharp, but there is also a quiet simplicity. In the vacuum of space, there is no air to scatter the light into a blue sky. There is no wind in the ordinary sense, no rustling trees, no distant hum. There is only light, darkness, and motion. The sun hangs in black space like a steady lantern, and around it, everything follows arcs that can be predicted, repeated, and trusted. We can let our attention rest on the idea of an orbit because an orbit is one of the gentlest stories in the universe. A planet is not being pulled straight inward, nor is it fleeing away. It is falling around the sun, continually, in a graceful compromise between forward motion and gravity's embrace. That falling becomes a path, and the path becomes a rhythm, and the rhythm becomes a kind of order. As we begin our outward glide, we do not need to measure the distance precisely. We can feel it in the way the light changes, gradually, as we move away from the sun's brightest presence. The sun remains large behind us for a while, but already we can sense that the solar system is built on spacing and patience. Worlds are not crowded together. They travel with room to spare, each keeping to its own lane in the great quiet roundabout. Not far from the sun, compared with the outer planets, a small world appears, dark and rock-like, with a surface that catches the sun's light and throws it back in sharp contrasts. This is Mercury, the innermost planet, a compact realm of stone and cratered plains. As we draw near, Mercury does not greet us with thick clouds or swirling bands. It is a world of exposed rock, where the landscape carries the memory of impacts. Its surface is marked by countless craters, ranging from tiny dimples to vast basins, with bright rays spreading outward like pale brushstrokes. Some of these rays are remnants of material thrown out during ancient collisions, still visible because there is so little weathering to erase them. On Mercury, time feels different because the rhythms of day and year weave together in an unusual way. The planet turns slowly and it circles the sun relatively quickly, and the result is a pattern of sunlight that lingers. Dawn, where it comes, can stretch into a long, gradual brightening. Sunset can be a slow easing into darkness. In some regions, the sun can appear to pause or drift strangely in the sky as Mercury's rotation and orbit interplay. This is not a place of rapid changes, but of extended intervals, long stretches of glare and long stretches of shade. The light here is unfiltered, harsh and clean, and the shadows can be as crisp as ink. Crater rims cast dark crescents onto crater floors. Mountains throw long, tapering shapes across plains. In the deepest basins, the bottom can remain in darkness for very long periods, protected from direct sunlight by the geometry of the terrain. Mercury has almost no atmosphere in the way we usually mean it. There is no thick blanket of gas to soften the temperature, no weather to blur the edges of the landscape. Instead, Mercury has a tenuous exosphere, a thin scattering of atoms that come and go, freed from the surface by sunlight and tiny impacts from space dust. It is a whisper of an atmosphere, barely there, more like a faint halo of particles than a sky. Because of this, the surface experiences extreme contrasts between sunlit and shaded areas. We can mention this gently, without lingering on discomfort. It is simply part of Mercury's character, this stark difference between warmth and cold, between illuminated rock and shadowed stone. The planet is, in a sense, an honest world. It does not hide behind clouds. It does not soften its features with haze. It shows itself plainly, like an old photograph with strong contrast, where every crater edge is clear. As we drift over Mercury's terrain, we see plains that appear smoother, where ancient lava once flowed and settled into broad, quiet surfaces. These plains are interrupted by craters, and in places they are crossed by long cliffs called scarps, where the ground has buckled and shifted. Mercury has cooled over time, and as it cooled, it likely contracted slightly, wrinkling its crust like skin that tightens. Those long cliffs can run for great distances, gentle in slope from afar, dramatic in their scale when you imagine standing at their base. One of the most notable regions on Mercury is a vast impact basin, a large circular scar from a collision long ago. Around such basins, the terrain can be complex, with rings of mountains and fractured plains. From above, the patterns feel like the ripples left in sand after a stone is dropped, except here the ripples are frozen into rock for ages. And then there is the quiet surprise of Mercury's poles. Even this sunlit near world can shelter ice, tucked into craters that never receive direct sunlight. In those permanent shadows, temperatures can remain low enough for water ice to persist, protected like a secret in the dark. It is a gentle reminder that space is a place of contrasts, and that simple rules like the angle of sunlight and the depth of a crater can create pockets of unexpected conditions. Mercury also carries a magnetic field, modest compared with Earth's, but present. It suggests that something within Mercury is still moving, perhaps a partially molten core, generating a field that reaches outward and interacts with the solar wind. It is a quiet, invisible feature, not something you see with your eyes, but something you can imagine as lines of force, a subtle structure wrapped around a small rocky sphere. If you find your attention drifting, that's perfectly fine. You can let the details soften as we continue. Mercury will keep turning, craters and cliffs and shadowed basins all keeping their places, while our cruise glides gently onward over its cratered face, following the line where daylight meets darkness, and watching the sun hang steady above a world of ancient stone. And then, with the same unhurried ease, we allow Mercury to fall behind us. In space, leaving a planet does not feel like pulling away from a shoreline. There is no spray, no wind, no receding sound. The planet simply becomes smaller, its details smoothing into a rounded shape, its crater rims and long cliffs turning into subtle shading. Mercury continues on its path around the sun, faithful to gravity, faithful to its own quiet rhythm, and we move outward into the open stretch between worlds. This space between planets is not empty in the absolute sense, but it is wonderfully uncluttered. Here and there, tiny grains of dust drift, leftovers from ancient collisions and slow crumbling, catching sunlight in faint, fleeting glints. The solar wind flows through, a steady stream of particles, thin as a thought, guided by the sun's magnetic patterns. Sometimes those patterns twist into broad spirals as the sun rotates, carrying its invisible structure outward like a gentle, rotating ribbon. The sunlight remains strong here, still bright and direct, still sharp enough to make shadows crisp on any solid surface. Yet even in this inner region, you can begin to feel the gradual softening that comes with distance. The sun is still the dominant presence, but it is beginning to look a little more like a source you can point to rather than a sky-filling blaze. Ahead of us, a new world begins to form from the darkness. At first, it is simply a bright point, more luminous than Mercury was, because it reflects so much light. It grows steadily, becoming a pale, glowing disk. This is Venus, wrapped in clouds so reflective that it often shines brilliantly in our own skies, near dawn and near dusk, like a calm lantern. As we approach Venus, the first impression is softness. Not softness of landscape, because the surface is hidden, but softness of appearance. Venus is veiled. Its atmosphere is thick with layers of cloud that circle the planet in broad, smooth sweeps. From a distance, the planet looks like a pearl, creamy and bright, with faint hints of swirling patterns. These clouds are high and extensive, and they reflect sunlight efficiently, sending much of it back into space. That reflectivity is part of why Venus appears so bright to us. It is, in its own way, a world made to catch light and hold it at the top of its sky, so that the planet wears a luminous cloak. The atmosphere itself is dense, and it changes the nature of light. If you could hover above the cloud tops, you would see sunlight scattered and softened, turning the sky into a pale glow rather than the hard black of open space. Here, the idea of a horizon becomes more subtle because haze blurs distance. The planet is still a sphere in space, still a solid world, but it is presented through a filter, as though you are always looking through a fine curtain. Venus's weather, high in the clouds, moves in a steady, sweeping flow. The upper atmosphere circles the planet more quickly than the surface rotates beneath it, a phenomenon sometimes described as the atmosphere's tendency to race ahead, as though the clouds are eager to keep traveling, even when the ground below turns slowly. It is a gentle reminder that a planet can have multiple rhythms at once: the pace of its orbit, the turning of its solid body, and the circulation of its air, each following its own rules. Venus's rotation is famously slow, and it turns in the opposite direction to many of the other planets. You do not need to hold that detail tightly. You can simply imagine that on Venus, sunrise and sunset are not quick events. The sun would take its time, lingering near the horizon, painting long, gradual transitions if you could see them from the surface. Venus asks for patience. It rewards long attention. Of course, the surface is not easily seen. The clouds are thick, and they do not part into clear windows. For a long time, Venus remained a mystery beneath its bright veil. From Earth, early observers could only see its changing phase, its waxing and waning shape, like a small moon. They could measure its brilliance, trace its path, and marvel at its beauty, but they could not see what lay beneath. We learned about Venus's hidden terrain by using waves that can pass through cloud, and by sending spacecraft that listened carefully to what the planet revealed. Radar, in particular, became a kind of gentle lantern for Venus, not of light, but of information. By sending out radio waves and measuring how they returned, scientists built maps of a surface that the eye could not reach. In this way, Venus's hidden world slowly came into focus, not as a sudden reveal, but as a patient gathering of detail. Beneath the clouds, Venus is a rocky planet, similar in size and mass to Earth, yet shaped by a different history. The maps show broad plains and highlands, and features that suggest ancient volcanic activity. Vast regions appear to have been resurfaced, as though flows of molten rock once spread and cooled into smooth expanses. There are mountains and ridges, and there are large circular features that hint at impacts, though the thick atmosphere would have filtered many smaller incoming objects over time, slowing them, softening their arrival. Volcanoes on Venus are part of the story that seems likely, because the planet shows so many volcanic forms. Some appear as wide, gently sloped shields. Others have more complex shapes, and some regions show patterns that look like fractured crust, as though the surface has been stretched and folded, reshaped by internal forces. Venus does not have the same style of moving crust that Earth does, with its large, shifting plates, but it has its own ways of renewing and rearranging its surface, guided by heat within and the slow strength of rock. The thick atmosphere also affects the way we imagine sound and light down below. If you were there, the sunlight would be dimmer and more diffuse through the haze, and the sky would be a brighter, more uniform glow. The landscape, if you could see it, might feel quieter in contrast than a rocky world under a black sky. Details would soften with distance. Shadows would not cut sharply. They would blur. It is a different kind of visual calm, created not by emptiness, but by layers of air. We can linger at the cloud tops again, where Venus is most visually approachable, and where the planet's mood feels gentlest. The cloud layers form bands and curls that drift around the globe. Sometimes they gather into subtle patterns near the poles, creating shapes that seem to spin like a slow pinwheel. These are not storms in the dramatic sense. They are large-scale patterns of circulation, turning because the planet turns, and because air flows from one region to another, always seeking balance. Even the idea of temperature on Venus can be held lightly, without harshness. Venus is warmer than Earth, and the thickness of its atmosphere is part of why. The planet receives sunlight and holds on to heat differently because its air is dense, and its clouds and gases interact with incoming and outgoing energy. This is not a story of alarm. It is simply an example of how atmospheres matter, how a planet's blanket of gas can shape the long-term feel of its surface. From our cruising distance, Venus remains tranquil, a bright sphere, a softly patterned veil, an elegant orbit around the Sun. We can appreciate it as a lesson in how two rocky planets can share similarities in size yet diverge in character, guided by differences in atmosphere, rotation, and geological history. And now, without haste, we continue outward. As we move away from Venus, it fades from a large disk into a bright bead of light, still noticeable because of its reflective clouds. In the inner solar system, light is plentiful. The Sun still dominates the view. But the space between planets begins to feel larger, as if the solar system is slowly opening its hands. Ahead lies Earth, our familiar world, though we will approach it with a respectful distance, keeping our tone gentle and observational. Earth, too, becomes visible first as a point, then as a small disk with subtle colour. As we draw nearer, we begin to see that Earth's brightness is not a single kind of shine. It is a mixture of reflective cloud, deep ocean, and land. The most striking thing about Earth from space is often its softness, not softness of ground, but softness of atmosphere. White clouds curl over the surface like slow brushstrokes, gathering into spirals, stretching into long bands, scattering into thin veils. Beneath them, the ocean appears as a deep, dark presence, absorbing light and giving the planet a calm, cool tone. Where land is visible, it shows in muted browns and greens, varied but gentle from afar. Earth's atmosphere creates a thin blue edge along the limb of the planet, a delicate line that is easy to overlook until you notice it. That thin line is a reminder that a great deal of Earth's character comes from a relatively small layer of gas wrapped around a rocky sphere. It is a fragile-looking boundary from this distance, and yet it is enough to shape weather, to scatter light, to support a complex surface environment. From here, day and night are visible as a gradual division across the globe, a soft curve where sunlight gives way to darkness. The boundary is not a hard line, because air scatters light and creates a band of twilight. That twilight can be imagined as a slow-moving zone, always circling, always shifting, never urgent. If you're still awake, that's perfectly all right. Nothing here is urgent. We can simply watch the planet turn. Earth's rotation is faster than Mercury's or Venus's, and that brings a familiar rhythm of day and night. But we don't need to measure it. We can just notice the sense of steady turning, the feeling that this world has a comfortable, practiced motion. The clouds move too, carried by winds, forming patterns that change even as the planet rotates beneath them. It is motion layered on motion, each with its own pace. Near Earth, there is also the presence of a companion, a smaller sphere that travels with it, keeping a stable partnership through gravity's gentle pull. From afar, Earth's moon appears as a pale, cratered disk, quieter in colour than Earth and far less veiled. It does not wear thick clouds. It does not blur its surface with haze. It shows its old face plainly, marked by ancient impacts, much like Mercury, though shaped by its own story. We will drift closer to that moonlight world soon, but for now we can hold Earth and Moon together as a pair, moving through space in a calm dance. They orbit the Sun together, and the Moon orbits Earth, and the arrangement is steady enough that it becomes, over time, a kind of background comfort in the story of the solar system. As our cruise continues, we keep our attention gentle and broad, letting Earth's blue and white presence pass without pulling us into anything too personal. It is simply a planet with oceans and clouds, a world with an atmosphere that makes it look alive from a distance, a sphere that turns quietly under sunlight. And as we glide beyond Earth's orbit, the Sun behind us begins, very gradually, to feel a little less overwhelming, and the path ahead begins to hint at a new kind of landscape, one where rocky plains and rust-coloured deserts will soon come into view, waiting calmly in the next stretch of our outward journey. And so we drift on, leaving Earth and its pale companion behind us, not with a sense of departure, but with the simple understanding that every world has its place, and our cruise is meant to keep moving gently outward, The space between Earth and the next planet feels like a long, quiet hallway. Sunlight still reaches us clearly, but it is already a touch less intense than it was near Mercury and Venus. The sun looks a little smaller. Its glare is still bright, still the main lamp of this region, yet the black around it seems to widen. In this widening, there is a certain calm, a sense that the solar system is roomy, patient, and generous with silence. As we travel, there are occasional small visitors, meteoroids, tiny fragments of stone and metal following their own orbits. Most are no larger than grains or pebbles, and they move without drama, tracing invisible paths. If they meet a planet with an atmosphere, they may briefly glow as they pass through. But out here, they are simply part of the gentle clutter of space, reminders that the solar system is not only planets, but also countless smaller pieces, each with a story that stretches back toward the system's earliest days. Ahead, another world begins to form, a dusty-toned sphere with a color that suggests iron-rich rock and fine powder. This is Mars, the next rocky planet outward, often beloved for its landscapes and its sense of open, desert-like space. From a distance, Mars appears smaller than Earth, but it carries a clear personality. Its surface shows darker and lighter regions, and sometimes a bright cap near a pole, like a pale patch catching the sun. As we approach, Mars becomes more detailed, and the first thing that feels noticeable is the clarity of its surface. Mars has an atmosphere, but it is thin enough that the planet's features still show sharply. There is haze at times, and clouds can form, and dust can lift into the sky, but much of the time the landscape is visible, carved and textured, a world of plains, basins, and towering forms. Mars is a planet of gentle extremes in scale. Not extremes in a loud, urgent way, but in the sense that it holds some of the solar system's grandest landscapes, presented in quiet stillness. There is a vast canyon system that runs for an enormous distance, like a long scar, with walls that step down into shadow and floor regions that stretch into the distance. There are volcanoes that rise high above surrounding plains, broad and shield-like, their slopes gentle enough to seem smooth from afar, yet immense in height and width when you picture them in full. We can let our attention linger over those volcanoes. On Mars, volcanic activity appears to have built some of the largest volcanoes we know of in the solar system. Their sheer size is partly a story of gravity and geology. Mars has lower gravity than Earth, and over long time spans, a volcano can build higher before its own weight becomes limiting. Also, Mars lacks the same global pattern of moving crustal plates that carries volcanic hotspots along on Earth, so volcanic regions on Mars may have stayed in place, allowing repeated eruptions in the same area to build great structures over time. From above, these volcanoes look calm. They are not erupting in our view. They are silent. Their summits are wide and often marked by large calderas, collapse features left when magma chambers emptied and the ground subsided. The slopes spread outward into surrounding plains like gentle hills, but they are hills the size of countries in scale, slow and patient in their presence. Mars is also a world shaped by impact. Craters dot the surface, especially in older regions where time has left its marks without fully erasing them. Yet Mars is not as uniformly cratered as Mercury. There are smoother plains where volcanic flows once spread, and there are regions where wind and dust have softened edges, rounding the crispness of some features and coating the surface with fine particles that drift and settle. Wind on Mars is a subtle sculptor. The atmosphere is thin, but it can still move dust. Over time, that dust becomes a kind of paint, covering surfaces in a fine layer, shifting with seasons, collecting in hollows, and sometimes lifting into the air to create hazy skies. From orbit, you can see patterns formed by dunes, ripples of sand-like material arranged by prevailing winds. These dunes gather into fields and lines, their shapes repeating with soothing consistency. The color of Mars often comes across as a soft rust, but it is not a single tone. There are regions of darker rock, areas where dust has been swept away, exposing basaltic surfaces. There are lighter areas where dust has accumulated. The planet is, in a sense, a canvas of wind and time, with patterns that shift gently but persist. If you could stand on Mars, the sky would not be the deep blue of Earth. It would more often be a pale, dusty hue, sometimes described as butterscotch or salmon-toned, especially when dust is suspended in the air. The sun would appear smaller than it does from Earth, and its light would feel a little thinner, as though the warmth of sunlight has begun to spread out and soften with distance. Shadows would still be clear, but they might be slightly less stark than on airless Mercury, because even a thin atmosphere scatters some light. Mars has seasons too, because it has an axial tilt not unlike Earth's. Over time, its poles change in brightness and extent. At the poles, caps of frozen material grow and shrink with the seasons. Some of that frozen material is water ice, and some is carbon dioxide ice, the same gas that makes up much of Mars's thin air. In winter, carbon dioxide can freeze out of the atmosphere and settle as frost, and in spring, it can sublimate back into gas. It is a slow breathing of the planet's air, a seasonal exchange between ground and sky. This is all quiet, distant, and steady. No urgency. Just a planet following rhythms. Mars also has small moons, little companions that orbit close by. They are not large enough to appear as dominant presences like Earth's moon. Instead, they are irregular and lumpy, more like captured asteroids or fragments than fully rounded spheres. Their names are often remembered because they sound like whispers of old myths, Phobos and Deimos. They circle Mars quickly, keeping close. Their surfaces are dark and cratered. Their shapes are not smooth but uneven, as though they never gathered enough mass to become round. We can take a gentle detour and glide nearer to one of them for a moment, without losing our outward course. Up close, a small moon like Phobos feels like a floating rock, a body with gravity so slight you could imagine a pebble drifting away if nudged too hard. Its surface is pocked with craters, and one crater is notably large relative to the moon itself, a scar that makes the moon look as though it has endured a heavy blow. There are grooves on its surface too, long, shallow channels that run across it. The origin of those grooves has been studied and discussed, and the safest way to hold the idea is simply that they are part of the moon's aged, stressed exterior, perhaps connected to impacts and to the gentle but persistent tug of Mars's gravity. Deimos, the outer of the two, is smaller and a bit smoother in appearance, coated with dust that softens the sharpness of its crater rims. Both moons move in their own quick loops, like small beads on invisible strings, always returning. And then, softly, we return our attention to Mars itself. Mars has long invited human curiosity. We have studied it through telescopes, watched its polar caps change, tracked its position in the sky, and eventually we sent spacecraft, which flew by, orbited, landed, and rolled across its surface. The details we have come from careful observation, from images that show layered rocks, from measurements of atmosphere and temperature, from the slow building of understanding, piece by piece. Some of the most soothing images of Mars are not dramatic at all. They are simple views of plains under a pale sky, a low hill, a distant ridge, the faint outline of a crater rim, shadows stretching gently across a field of stones. In those scenes, Mars looks like a quiet desert, vast and open, with the kind of stillness that can make the mind feel spacious. There are ancient river-like channels, too, carved into the land. Their shapes suggest that liquid once flowed there, long ago, when conditions were different. Again, we can hold this gently. Mars's surface bears signs that in its distant past, water may have been more present, perhaps in rivers, lakes, or seas. Today, the surface is dry and cold, and water is mostly found as ice, locked away in polar regions and beneath the ground in places. But the landscape remembers. You can see that memory in branching valleys and sediment-like formations. Even the idea of a dry riverbed is quiet. A channel that once carried water, now empty, still shaped as though it expects the flow to return, though it may not. It is a story of time and of change, told in stone. You don't need to keep every detail. Mars can simply be a passing view, a rust-coloured sphere turning calmly under a smaller sun, its deserts and volcanoes and canyons resting in quiet. As we leave Mars behind, we begin to sense the next major transition in our cruise. Beyond Mars lies the asteroid belt, a region often misunderstood as a dense field of tumbling rocks, crowded and dangerous. In reality, the asteroid belt is spacious. Its objects are scattered, separated by vast distances. It is more like a wide, sparse neighborhood of small bodies than a packed wall of stone. As we drift outward toward that region, the sunlight continues to thin gradually. The sun is still bright, still the central lamp, but it feels more distant. Shadows remain, but they begin to feel less harsh. The space between worlds begins to feel even larger. Before we fully enter the asteroid belt, it can be soothing to picture Mars as a small, steady point behind us, and ahead, a faintly populated zone of objects that orbit quietly between the rocky planets and the giants. We are moving from the inner solar system's rocky intimacy into a broader realm, where the next worlds will be enormous, banded, and ringed, and where moons will become worlds of their own. But for now, we are still in the gentle drift between Mars and the belt, with a calm, dark sky around us, and the sun behind, shining steadily, asking nothing, offering light in a simple, patient stream. That light follows us as we move outward, but it spreads and softens with distance, becoming less of a glare and more of a clear, steady glow. The sun remains the same sun, unchanging in its place at the center, yet our perspective shifts, and with it, the feeling of the space around us. The inner planets are now behind, small and bright points in their familiar lanes. Ahead, the next region of our cruise begins to reveal itself. At first, there is no sudden border, no sign that announces arrival. The asteroid belt is not a gate you pass through. It is simply a broad zone where small bodies are more common than they are elsewhere, each one orbiting quietly, each one keeping to a path shaped by gravity and time. In the wide quiet between Mars and Jupiter, the belt is often imagined as crowded, like a dense field of rocks close enough to brush against. In reality, the belt is spacious. You could travel through it for a very long time and see nothing close by at all. The objects are separated by distances that are, to the human mind, enormous. And yet, in this vastness, there is a different kind of presence, a gentle sense of company. Not the company of a single large world, but the company of many small ones, scattered like seeds across a very wide garden. As our cruise glides onward, a small body appears, then another, each first noticed as a faint moving point against the steady background. Some are darker, absorbing light. Some are brighter, reflecting more of the sun's glow. Some are irregular, shaped like worn stones. Others are more rounded, having gathered enough mass to pull themselves toward a sphere. These bodies are leftovers, in a sense, from the solar system's early days, when the sun was new and the disk of material around it was full of dust and rock and ice. In that early time, grains collided and stuck together, forming larger pieces. Some became the cores of planets. Others remained smaller, never fully assembled into a larger world, their growth interrupted by gravity's complex tugs and the influence of nearby giants. In the belt, you can feel that early history without needing to force it into a dramatic narrative. It is simply a region where the building blocks remain visible, where the solar system keeps a collection of fragments that never quite became a single planet. They orbit with patience, each one following the same basic rule: move forward and fall around the sun. We can drift near one of the larger bodies, a rounded world that stands out because it has achieved a kind of completeness. This is Ceres, often described as a dwarf planet, the largest object in the asteroid belt. From a distance, it looks like a gentle sphere, subdued in brightness, neither dazzling nor dark. As we approach, its surface reveals subtle variations, faint contrasts of tone, and hints of brighter patches. Ceres is interesting not because it is loud, but because it suggests complexity beneath a quiet exterior. It appears to contain a significant amount of water ice mixed with rock, and there are signs that its interior may have been, or perhaps still is in some limited way, active in a slow, muted sense. Bright areas on its surface have been studied as deposits of reflective material, likely salts left behind as briny liquids reached the surface and changed in the cold vacuum. Nothing about this needs urgency. It is simply the gentle wonder of a small world that has its own internal story, its own chemistry, its own slow adjustments over time. The idea of brine, of salty water on a small body far from the sun, can feel quietly astonishing. It suggests that even in places where sunlight is thin and temperatures are low, nature can arrange itself into layered processes. Ice can melt under pressure or heat, minerals can dissolve and travel, materials can be brought upward, and when they meet the surface, they can freeze or evaporate, leaving behind a bright signature like pale dust on dark stone. Ceres also reminds us that the boundary between planet and non-planet is less important than the reality of what a world is. A world is any body with its own shape, its own gravity, its own relationship with sunlight and shadow. By that simple measure, Ceres is very much a world, quietly turning as it orbits, keeping a steady pace in the middle distance between the inner planets and the giants. Not far away in this same region, another large asteroid invites attention for different reasons. Vesta is smaller than Ceres and not fully rounded, but it has a strong identity. It is brighter than many asteroids, and it shows signs of having been shaped by heat early in its history, with a layered interior, more like a small planet that never finished growing. Vesta's surface carries the scars of large impacts, including a vast cratered region near one of its poles, a place where collisions carved away material and left a dramatic, yet still silent, landmark. Even the word crater here can be softened. A crater is simply a memory of an encounter, a mark left in rock by an object arriving from space. There is no need to imagine the moment itself. We can focus on the result, a basin, a rim, a field of ejecta, all frozen into place, all patiently illuminated as the asteroid turns. Around us, the belt continues. Some bodies are carbon-rich and dark, their surfaces absorbing much of the sunlight. Others are more stony. Some contain more metal, hinting at the variety of the early solar system's materials. In these differences, you can feel the belt as a kind of archive, a collection of samples from different distances and temperatures from different parts of the original disk. You can let this become a slow drift through a museum of small worlds, each one passing gently by. Some asteroids travel alone. Others belong to families, groups that share similar orbits, because they were once part of the same parent body before a collision broke it apart. Over long periods, those fragments spread out, but they keep a related pattern, like pages torn from the same book drifting into neighboring shelves. And then there are the ones with companions of their own. A few asteroids have tiny moons, even smaller rocks that orbit them. These are miniature systems, small gravity wells, holding smaller pieces close. The thought is soothing in its repetition. Gravity works the same way at every scale. Whether it is a moon around a planet or a pebble around an asteroid, the motion is a gentle compromise between fall and forward travel. If we listen to how we know these things, the story remains calm and steady. We have seen these bodies with telescopes, watching their light brighten and dim as they rotate, learning their shapes from the way their reflections change. We have flown spacecraft through the belt, taking images as they pass, measuring the dust environment, and sometimes orbiting a major asteroid long enough to map it in detail. This knowledge has been gathered with patience, with repeated observation, with the slow accumulation of clarity. The belt also invites a quiet kind of scale. From here, the sun is less intense than it was near Mercury, and the warmth of sunlight feels gentler. Shadows remain crisp in places, but the overall lighting is calmer, less glaring. The background of stars is always present, steady and unblinking, not twinkling as they do through Earth's air. A star field in space is like a fixed tapestry, and as we move, our angle changes slowly, and the tapestry shifts with almost imperceptible grace. In this region, you can imagine dust as a slow-moving presence. Fine grains can drift, influenced by sunlight in subtle ways. Over long times, radiation can gently nudge tiny particles, altering their orbits bit by bit. Even light in space has a delicate pressure, a small push that becomes meaningful only over great patience. It is another example of the solar system's preference for slow change. As we continue outward, the belt begins to thin again, the density of objects decreasing as the orbits spread and the region gives way to the realm dominated by the next planet. And the next planet, even from far away, announces itself not with sound or flashing, but with scale. Jupiter is ahead, and it grows from a bright point into a disk, then into a presence. It reflects sunlight strongly, and it sits in the outer portion of the solar system like a great anchor. As we approach, we begin to see banding, faint at first, then clearer. Broad stripes of cloud, light and dark, wrapped around a world made not of solid ground, but of deep atmosphere. Before we arrive fully, it can be soothing to notice how the character of the journey changes here. Between the inner planets, the destinations were rocky and relatively close together. Here, the distances have expanded. The solar system is entering its wide, spacious middle, where giant planets take long, slow paths and carry large families of moons. Jupiter's size becomes apparent as we draw nearer. It is enormous compared to the rocky worlds we have just visited. Its gravity is strong enough to shape the region around it, to shepherd groups of small bodies, to influence the paths of comets and asteroids over time. But we do not need to frame that as danger. It is simply influence, the quiet authority of mass. The planet's cloud tops are the first thing we meet visually. They form a layered atmosphere of pale creams, soft tans, and muted browns, arranged in bands that circle the planet. These bands are shaped by winds that flow at different speeds in different latitudes, creating alternating zones where air rises and falls, where clouds gather or thin. The patterns are broad and smooth, like brushwork on a sphere. In places, storms appear as ovals, some small and some large, turning slowly within the banded flow. Jupiter's storms can persist for long periods, and this longevity is part of what makes them feel so soothing to observe. They are not quick flashes. They are slow, rotating systems embedded in the planet's rhythm. One storm, especially famous, sits like a long-lived mark on Jupiter's face, a large oval that has been observed for centuries from Earth. It changes over time, subtly, but it remains recognizable as a persistent feature, a calm reminder that even storms can become steady, almost familiar, when they are part of a planet's ongoing circulation. The sunlight here is noticeably fainter than it was near Earth, yet still bright enough to reveal detail. Jupiter's clouds catch the light and cast gentle shadows within their own layers, giving the planet a sense of depth. The planet turns relatively quickly, and that rotation helps shape the bands and the winds, though we do not need to hold the exact pace in mind. We can simply feel that Jupiter is a fast spinner, a world where day is short compared to the long, slow years of the outer solar system. As we glide closer, Jupiter fills more of our view, and a new set of destinations appears around it. Moons, large enough to be worlds in their own right. Some are rocky and cratered, some are icy and bright. Some show hints of geological activity, reshaping their surfaces in slow, ongoing ways. They are the Galilean moons, among the most famous companions in the solar system, and they offer us gentle detours, little side journeys that still keep us on our outward path. We will visit them soon, one by one, lingering where the wonder is calm and the motion is slow, letting Jupiter's vast striped presence steady the background as our cruise drifts into its wide and quietly magnificent domain. And as we drift closer, those moons become more than points of light. They become rounded shapes with their own textures, their own shades, their own quiet personalities, each one moving along a calm path around the giant planet. The first thing to notice is how natural it feels for Jupiter to have companions. A world so large seems, almost by instinct, to gather a family. These moons do not hover randomly. They travel in steady, repeating loops, held by Jupiter's gravity the way leaves can be carried in a slow eddy of water, circling and circling, never needing to rush. Even from a distance, the moons differ in brightness and tone. Some are pale, catching sunlight with a soft sheen. Others are darker, more subdued. As we ease nearer, we can begin with the moon that appears most active in appearance. Not because it is loud, but because its surface looks freshly changed. Io comes into view as a world mottled with warm colours, with patches of yellow, orange and darker tones, as though the surface has been painted and repainted. Unlike many moons, Io does not present a landscape dominated by ancient craters. Instead, it looks younger on the outside because its surface is renewed by internal activity. This renewal is driven by a gentle tug of war, not a conflict, but a constant flexing. Jupiter's gravity, combined with the influences of neighbouring moons, subtly kneads Io's interior, bending it slightly as it orbits. That repeated flexing creates heat within, and heat over long periods can reshape a world. From above, Io's surface can look like a quilt of different materials. There are broad plains, and there are regions that suggest flows, as though something has spread outward and cooled. There are also dark spots and rings that have been associated with volcanic areas, places where material has reached the surface. The idea of volcanoes in the outer solar system can feel quietly astonishing. It reminds us that warmth is not only a gift of sunlight, it can also come from motion, from gravity's steady pull, from the slow flexing of rock deep within. You do not need to picture eruption or drama. You can picture simply a world that is warmed from inside, that carries its heat upward in a patient way, leaving fresh patterns across its face. In that sense, Io is like a living sketchbook, always adding new lines. As we drift onward, we turn our attention to a moon with a different kind of wonder, one that seems calm and bright, with a surface of ice that catches light softly. Europa appears as a pale sphere marked by long, dark lines that stretch across its surface in gentle arcs. These lines intersect and curve, forming a delicate web. They give Europa a look of quiet intricacy, like thin cracks in old porcelain or the subtle veining in marble. The surface is icy, and it seems relatively smooth compared to many cratered worlds, suggesting that it has been renewed in some way. Here, the wonder is in the thought that beneath the ice, there may be a layer that behaves more fluidly, perhaps an ocean of liquid water beneath an icy shell. We can hold this as a possibility supported by multiple lines of evidence, without needing absolute certainty in our tone. Europa's surface patterns and the way it responds to Jupiter's gravity suggest an interior that is not entirely rigid. Again, the the theme returns. Gravity as a gentle shaper, pulling and releasing, warming by flexing, creating slow internal motion. If there is an ocean beneath Europa's ice, it would be hidden, dark, and calm, insulated from the cold of space by the shell above. The ocean, if it exists, would not be a place of waves under wind. It would be a place of slow currents, guided by heat and chemistry, by subtle differences in temperature and salt content, by the quiet physics of fluid motion. The concept is soothing precisely because it is so sheltered. A sea beneath ice, far from the sun, held in a steady embrace by a moon's gravity and a planet's pull. On the surface, the ice tells a story of stress and movement. The lines suggest that the shell has cracked and shifted. In places, blocks of ice may have moved relative to one another, like plates on a frozen lake that has been gently pressed and pulled. Some regions look as though the surface has been resurfaced, perhaps by warmer ice welling up from below, or by the freezing of material that reached the surface and spread. None of this needs urgency. It can simply be a quiet contemplation of how many ways there are for a world to be active, not only through wind and rain, but through internal warmth and slow ice dynamics, through the steady kneading of gravity. If you're still awake, that's perfectly all right. You can let these details drift by like faint clouds and simply hold the image of Europa as a pale moon with graceful lines turning slowly in Jupiter's distant light. Next, we glide toward the largest of Jupiter's moons, a world that feels, even from afar, substantial and complete. Ganymede is large enough to have its own layers of history written across its surface. It appears as a mix of darker, older regions and lighter, grooved terrain, as though the crust has been stretched and patterned in long, sweeping textures. This combination gives Ganymede a look of depth, like a landscape that has experienced multiple eras. The darker regions are more heavily cratered, suggesting ancient surfaces that have remained exposed for long stretches of time. The lighter areas show grooves and ridges, as though the ice and rock have been pulled and reshaped. These grooved terrains can appear in broad bands, curving and intersecting, creating a sense of motion frozen into the crust. Ganymede carries another quiet distinction. It has a magnetic field of its own, a rare trait for a moon, suggesting a complex interior with conductive material moving deep inside. Magnetic fields are invisible, but they shape the environment around a world. They can guide charged particles, sculpt auroras, and create a protective bubble within a larger magnetic realm. In Jupiter's system, this becomes a layered dance, with Jupiter's vast magnetic influence and the smaller fields of moons interacting in subtle ways. You can imagine magnetic field lines like fine threads looping from pole to pole, stretching outward, connecting and reconnecting, always present, always unseen, like the structure of a gentle current in a river you cannot see, but can infer from the way leaves drift. And then there is Callisto, the outer of the four large moons, often quieter in its expression and deeply cratered. Callisto's surface looks ancient and calm, covered with impacts that have accumulated over immense spans of time. Its appearance is darker than some of its neighbours, and its craters overlap and crowd, as though the moon has simply been present and patient, accepting what space brings, keeping each mark as part of its memory. Callisto's craters can have bright rims and subtle rays, and in some places large circular features show multiple rings, as though the crust responded to an impact by rippling outward. The surface is like a record, a long archive etched in ice and rock. There is something soothing about a world like Callisto. It does not demand interpretation. It does not look newly changed. It simply is what it has become through time. A quiet, cratered face turned to the sun, moving through shadow and light as it orbits Jupiter. As we drift among these moons, Jupiter remains in the background, filling a portion of the sky with its banded clouds. The planet's stripes shift subtly as we move, and the large oval storm remains a familiar mark, slowly rotating within the broader flow. The clouds are not a single flat layer. They have depth, with higher and lower regions, and the banding reflects differences in chemistry and temperature and circulation. From afar, the colors are gentle, more like creams and tans than sharp contrasts. Jupiter's atmosphere is deep. The cloud tops we see are only the uppermost expression of a much thicker envelope of gas. As you go deeper, pressure increases, and the nature of the gas changes. In the depths, hydrogen behaves differently, compressed and altered by the immense weight of the atmosphere above. This transition is not something we need to picture precisely. It is enough to sense that Jupiter is a world where the familiar idea of surface gives way to layers, each one becoming denser and stranger as you descend, until the very concept of solid ground becomes less relevant. This layered nature makes Jupiter feel like a planet made of gradients, not a place where you stand, but a place where you float through densities, where clouds give way to thicker clouds, where gas becomes more compressed, where the planet is a great sphere of material in slow motion. Around Jupiter, there is also a system of rings, faint compared to Saturn's, but present. Jupiter's rings are more subtle and dusty, a delicate halo rather than a brilliant band. They are made of tiny particles, likely replenished by impacts on small moons that release dust into orbit. You can think of them as a soft veil, barely noticeable, more like a suggestion of structure than a showy display. And then there is Jupiter's magnetic environment, enormous and complex. The planet's rapid rotation and internal structure generate a powerful magnetic field that stretches far into space, forming a wide region where charged particles are guided and shaped. This magnetosphere interacts with the solar wind, creating boundaries and flows, like an invisible weather system made of particles and fields rather than air and water. Where those particles meet Jupiter's upper atmosphere near the poles, auroras can form, luminous ovals that glow in wavelengths beyond ordinary human sight, and sometimes within it, depending on the conditions and instruments used to observe them. Even if you don't picture the colors, you can picture the concept as gentle. Particles guided along invisible lines, arriving and releasing energy as soft light, like a quiet signature written at the edge of a giant planet sky. If any thought of energetic particles arises, you can let it pass without concern. We are observing from a comfortable distance in imagination, and nothing here is urgent. It is simply part of how a large planet interacts with its surroundings, a physics of flow and guidance, steady and predictable over long periods. It can be calming to consider how much of Jupiter's story is about rotation. The planet spins, and that spin shapes the bands. It shapes the winds. It shapes the magnetic field. Rotation is a kind of continuous action that does not require effort. It is simply momentum preserved, a gift from formation, maintained by the emptiness of space where friction is minimal. And as Jupiter turns, its moons continue their orbits, each one tracing the same routes, returning again and again. The entire system is a set of nested cycles, the Sun at the center, Jupiter circling, moons circling Jupiter, and within all of that, the slow drift of smaller bodies and dust. It is repetition in the most natural sense, the kind of repetition that can soothe the mind because it feels stable. Now gently, we begin to let Jupiter recede. This does not happen quickly. Jupiter is so large that it remains a prominent presence for a long time. But gradually, as we continue outward, the banding becomes less detailed, the moons become points again, and the planet becomes one bright world among others, still commanding, still luminous, but no longer filling the view. Ahead lies the next great planet and the next great shift in the mood of our cruise. Saturn waits farther out, where sunlight is thinner and the sky feels even wider. Even from a distance, Saturn has a distinctive signature, a shape that does not match the simple disk of a planet alone. Around Saturn, there is a pale, extended structure, a flattened halo that catches the sun and draws a quiet line through the dark. Saturn's rings begin as a thin suggestion, like a delicate stroke across the planet. As we approach, they become clearer, and a particular kind of wonder settles in. Rings are among the most soothing structures in the solar system because they embody gentle motion. Countless particles, each one following its own orbit, together forming a broad, luminous band. It is complexity made calm by repetition. For now, we are still in the space between giants, with Jupiter behind us and Saturn ahead, and the Sun smaller than it has been before, still bright, still steady, but more distant, as though we are moving into a quieter room, where the lamp is farther away and the shadows are softer. If you're still awake, that's perfectly all right. You can simply drift with the cruise, letting Jupiter's vastness become a memory behind, and letting Saturn's rings, faint and inviting, draw us onward into the next calm region of the solar system. The space between Jupiter and Saturn feels especially spacious, as though the solar system has taken a long breath. The sun now seems smaller in the sky behind us, still bright, still the central lantern, but less overwhelming. Its light arrives more gently, and the darkness around it feels deeper, more complete. Stars remain steady, sharp points that do not twinkle, a calm backdrop that makes the slow movement of planets feel even more serene. Saturn grows gradually from a pale point to a small disk, and then to a recognizable world with a softly golden tone. And the rings, once a faint line, become a wide luminous band, encircling the planet like a graceful sculpture. As we approach, the first impression is not of a single ring, but of many. The rings are layered, with variations in brightness and density, with subtle divisions and gaps that give them texture. They are made of countless pieces, most of them ice, ranging in size from grains to chunks, each one orbiting Saturn as faithfully as any moon. Each piece follows the same basic rule: move forward and fall around the planet, held in a steady arc by gravity. There is something deeply soothing about that image. Many small things, each doing the same simple motion, together making a structure that looks elegant and almost still from afar. Yet the rings are not static. They are constantly in motion, particles circling, occasionally colliding gently, reshaping the ring's fine structure over time. In that way, the rings are like a slow river made of ice, flowing not inward but around. The rings catch sunlight and reflect it, making them bright against the black. Their brightness changes with angle. Sometimes, from certain perspectives, they appear more luminous. From other angles, they can look thinner, more delicate, even nearly invisible when viewed edge-on. This changing appearance is part of their quiet charm. It is a reminder that what we see depends on viewpoint, and that the solar system offers different moods depending on where you are looking from. Saturn itself, beneath the rings, is a giant world of gas, like Jupiter, but more subtly coloured. Its cloud bands are present, but often less contrasted than Jupiter's, giving Saturn a smoother, gentler look. The atmosphere shows pale yellows and soft creams, sometimes with faint banding. Storms can occur, and Saturn has its own weather, but the overall impression is calm, as though the planet's clouds are painted in lighter strokes. Saturn's rapid rotation shapes its form. Like other giant planets, it spins quickly enough that it bulges slightly at the equator, becoming a little flattened at the poles. This is a quiet consequence of rotation, another example of how motion shapes a world without any drama. A spinning planet becomes subtly wider in the middle, and the rings, too, align with that equatorial plane, forming a wide disk around the planet's waist. The rings are not all the same. There are regions that appear bright and dense, and regions that are thinner and darker. There are named divisions, but we do not need to recite them. We can simply notice that the rings contain patterns, and those patterns come from gravity's gentle sculpting. Moons, orbiting within and near the rings, can create gaps and waves. Their gravity nudges ring particles, gathering them into edges, carving out clear separations, and creating spiral patterns that propagate through the ring like ripples. This is one of the most soothing kinds of physics to contemplate. A moon moves along its orbit, and its gravity, reaching outward, tugs on countless particles. That tug, repeated with each orbit, can create a persistent structure, a gap that remains clear, a sharp edge, a wave that travels. It is like a steady hand drawing patterns in sand, but the hand is gravity and the sand is ice, and the drawing takes place over years and centuries. We can take a gentle detour into the rings themselves, not as a descent, but as a closer look. Imagine drifting above the ring plane, seeing the particles below as a glittering field. The ring is wide, stretching far from Saturn. The particles are spaced, but there are so many that together they form a bright band. Sunlight comes in at an angle, and each piece of ice catches a tiny highlight, a scattered constellation of reflections. Shadows fall too, each particle casting a faint, narrow shade on particles below or on the ring plane, creating a delicate interplay of light and dark. In places, ring particles gather into denser lanes. In other places, the ring becomes more translucent. There are thin ringlets, narrow bands within the broader ring system, each with its own density and texture. If you could linger long enough, you might see subtle waves like gentle corrugations caused by gravitational resonances. These waves are not water waves. They are patterns in the distribution of particles, a crowd moving in coordinated fashion under the influence of repeated tugs. Saturn's rings, for all their beauty, are also a reminder that the solar system is full of small-scale motion. Not only planets and moons, but also dust and ice grains, each with an orbit, each with momentum, each following simple rules that create complex shapes. Now, as we pull our focus back to Saturn as a whole, we see that the planet is surrounded by many moons, a large family, some small and irregular, some large and richly textured. Among them, a few stand out as especially inviting for calm detours. Titan is one of Saturn's most famous moons, and even from a distance it feels distinct because it is wrapped in a thick atmosphere. Titan's atmosphere gives it a hazy, orange-brown appearance, as though the moon is wearing a soft veil like Venus, but in a colder, more distant form. This haze obscures the surface in visible light, creating a world of suggestion rather than sharp detail. Titan's atmosphere is dense compared to most moons, and it creates weather and a sense of sky. Beneath the haze, Titan has landscapes shaped by rivers and lakes, not of water in the usual sense, but of hydrocarbons like methane and ethane, which can be liquid in Titan's cold environment. This is a gentle kind of wonder. The idea that a moon far from the sun can have rain, rivers and lakes, though made of different substances, is quietly astonishing. It expands the imagination of what weather can mean. We can picture Titan's surface softly, not as a harsh alien world, but as a calm place under a muted sky. There may be dunes of dark grains arranged in long parallel lines. There may be winding channels carved by flowing liquid. There may be smooth lake surfaces reflecting faint sunlight that filters through haze. The light at Titan is dim, the sun small, and the overall scene can be imagined as a kind of permanent twilight, gentle and subdued. Then there is Enceladus, a smaller moon with a bright, icy surface. It appears almost luminous, reflecting sunlight strongly. Enceladus has captivated observers because it shows signs of activity near its south pole, where material has been seen escaping into space, forming a plume of ice particles and vapor. Again, we do not need to picture this as dramatic. We can picture it as a gentle release, a slow venting from a warm interior. This activity suggests that beneath Enceladus's icy crust, there may be a subsurface ocean warmed by tidal forces, much like Europa. The idea repeats soothingly. Gravity flexes a moon. The flexing creates heat. The heat allows water to remain liquid beneath ice. The ocean remains hidden, sheltered, calm. And occasionally, material from within finds a path to the surface and beyond, adding tiny particles to space. Those particles can contribute to Saturn's ring system. In fact, one of Saturn's faint rings is associated with Enceladus's orbit, as though the moon is gently feeding the ring with its icy grains. It is a beautiful, calm relationship. A moon quietly shedding material, and a ring quietly collecting it, both held in place by Saturn's gravity. Saturn has other moons too, each with its own look. Some are cratered and dark like old stones. Some are bright and icy. Some show fractures and ridges. Some have unusual shapes. Together they form a complex family, orbiting at different distances, each one keeping a steady pace. Saturn's system also has a magnetic field, though it is more subtle in some respects than Jupiter's. It still creates a magnetosphere, interacting with the solar wind, guiding particles and producing auroras near the poles. The presence of rings adds complexity. as charged particles interact with ring material and with the tenuous gases that can exist around the moons. Again, this is invisible structure. You do not see it with your eyes, but you can imagine it as a gentle architecture of forces. As we drift, the rings remain the central visual. Their geometry is calming, a broad disk around a planet, tilted slightly, casting shadows onto the cloud tops below. In certain lighting, the ring's shadow can be seen as a dark band across Saturn's atmosphere, a soft line that moves with the planet's rotation and with the changing angle of sunlight. The planet's own shadow can fall on the rings too, creating a wedge of darkness that slices through the bright band like a quiet eclipse. These shadows are not frightening. They are simply shapes, evidence of three-dimensional space, evidence that light travels in straight lines and that objects block it. The shadows move slowly as the planet and rings keep their steady orientations. You can let the rings become a gentle pattern behind your eyelids, a bright arc in darkness, repeating the same calm curve. Now, slowly, we begin to continue outward once more. Saturn, like Jupiter, remains visible for a long time because it is large and bright and ringed. But as we travel farther away, the rings narrow in apparent size. The planet shrinks, and its moons become points again, each one continuing its orbit without our attention. Ahead lies Uranus, a planet that often feels like a quiet secret of the solar system. It is far enough away that sunlight becomes noticeably faint. Its color is subdued and cool, a pale blue-green tone. It carries an unusual orientation, an axial tilt that makes it seem as though it is rolling along its orbit. And it has its own family of moons, its own rings, and its own gentle story of seasons that last a long time. As Saturn recedes behind us, the solar system grows calmer still, as though we are moving into a deeper night. The sun becomes smaller, its warmth more distant. The space between giant planets stretches, and our cruise becomes even more unhurried, even more quiet, with the next destination waiting far ahead, patient and still. It waits in the way distant things do in space, without impatience and without movement that feels obvious to us. Uranus is there, already travelling along its orbit, already turning in its own quiet way, but from where we are now, it is a small bead of colour in a vast, dark room. As we glide onward, the feeling of distance becomes part of the comfort. The solar system is no longer a cluster of nearby destinations. It is a set of wide intervals, long spans where nothing changes quickly, where the only motion is the steady, almost invisible shift of perspective. The sun behind us is smaller now, more like a brilliant star than a dominating disk. Its light still arrives cleanly, still able to cast shadows, but the warmth of it is gentler and more remote, as if the brightness has been carefully diluted by the immensity of space. In these outer regions, the cruise becomes quieter in a particular way. There are fewer familiar shapes. The inner planets are no longer obvious companions. Even Saturn, with its rings, begins to fade into a bright, ringed point behind us, a delicate symbol rather than a full presence. Ahead, Uranus slowly grows, and with it, the subtle palette of the distant solar system comes into view. Here, the star field feels especially crisp. There is no atmosphere to blur it, no twinkling, no softening. The stars hold steady, and our motion simply changes their arrangement by tiny degrees. You might notice how calm it feels to look at something that does not flicker, something that remains fixed. In that steadiness, the mind can rest. If you're still awake, that's perfectly all right. You can let your attention float. Nothing here requires focus. The solar system will continue to move, whether we watch it or not. As Uranus becomes more distinct, its first gift is colour, a pale blue-green, subdued and cool, like a softly tinted glass. This colour comes from the way its atmosphere interacts with sunlight. The upper layers contain gases that absorb some wavelengths more than others, leaving this calm, aquatic hue. It is a colour that seems made for quiet contemplation, especially in the thin sunlight of this far distance. Uranus is not a rocky sphere. It is a giant planet, but different from Jupiter and Saturn. Where those two are dominated by thick envelopes of hydrogen and helium, Uranus belongs to a quieter category, sometimes called the ice giants. The name can sound harsh, but the idea is gentle. It simply means that the planet's interior likely contains large amounts of substances that, far from the Sun, can exist as fluids or solids under great pressure. Materials like water, ammonia, and methane, mixed in complex ways. Above that interior is an atmosphere of light gases, forming the visible face we see. As we approach, Uranus appears smoother than Jupiter or Saturn. Its cloud bands are subtle, sometimes almost indistinguishable, as though the planet is wrapped in a soft, uniform layer. This is not because nothing is happening, but because the contrasts are less pronounced in visible light, and because the atmosphere can be calm in appearance at times. When clouds do form, they can appear as faint bright spots or gentle streaks, like small brush marks on a pale sphere. Uranus turns, and it does so with an orientation that makes it feel especially unusual. Many planets spin with their axis more or less upright relative to their orbit, like a top that leans only slightly. Uranus is different. Its axis is tilted so dramatically that it can seem to roll along its path, presenting its poles more directly toward the Sun at different times. This tilt creates seasons unlike those on any other planet. Seasons that are not simply a slight change in sunlight angle, but a major reorientation of which hemisphere faces the Sun for long stretches. You do not need to measure these seasons. You can simply imagine them as very long, very patient cycles of illumination. For a long time, one polar region can bask in continuous daylight, while the other remains in prolonged darkness. Then, slowly, over the course of the planet's journey, that balance shifts. Dawn and dusk on Uranus can be a long, drawn-out transition, like a slow turning of a lamp in a dark room. The Sun from Uranus is still bright enough to define day and night, but it is smaller, less commanding. Light feels more delicate here, as though it arrives with a lighter touch. Shadows, where they fall on solid surfaces, would still be crisp, but much of what we see is atmosphere, and the atmosphere turns sunlight into a softer gradient. Around Uranus, we begin to notice a faint ring system. It does not blaze like Saturn's. Uranus's rings are darker and narrower, more understated, like thin charcoal lines drawn around the planet. Their subtlety is part of their charm. They are not asking to be the main attraction. They are quiet structures discovered through careful observation, revealed when the planet passed in front of a star and the star's light dimmed in a precise pattern, as though something thin and orderly had briefly blocked it. Those rings are made of particles too, likely darker, less reflective material than Saturn's ice-bright grains. They form narrow bands, and they can be shaped by small moons that travel nearby, shepherding ring particles into confined lanes. This shepherding is one of the most calming ideas in planetary systems. A moon, small and steady, keeps moving along its path, and its gravity gently organizes countless particles, maintaining edges and gaps without any direct contact. It is order created at a distance, a kind of invisible guidance. Uranus has moons as well, and as we glide closer, these companions begin to separate from the background. Some are small and close to the rings, others are larger and farther out, more substantial worlds with their own landscapes. The larger moons of Uranus are icy and dark, each with a different blend of cratered plains and fractured terrain. One of the most visually intriguing among them is Miranda, a smaller moon that looks as though it has been assembled from different pieces. Its surface shows patchwork regions, with cliffs and ridges and oddly shaped features that create a sense of varied history. There are steep scarps, like walls that drop abruptly, and there are patterns that suggest the crust has been broken and rearranged. Miranda can feel like a quiet collage, a moon that has been reshaped by impacts and internal stresses, leaving behind a terrain that looks complex even in stillness. Other major moons, like Ariel and Umbriel, offer a gentler contrast. Ariel can appear brighter and shows signs of past resurfacing, with smoother areas and long valleys, suggesting that at some point its interior warmth may have helped reshape the crust. Umbriel is darker, more heavily cratered in appearance, a moon whose surface holds onto its older marks. Then there are Titania and Oberon, larger moons farther out, with landscapes of craters and long fractures, icy worlds that have endured time and carry it on their faces. As we drift among these moons, their movement is slow and steady, each one circling Uranus with patient regularity. From the vantage of our cruise, the system feels like a quiet mobile, balanced and orderly. Rings in thin lines, moons in calm loops. The planet itself turning with its unusual tilt, like a sphere rolling gently through its own seasons. We can pause our attention on the idea of that tilt again because it shapes everything around Uranus. If a planet's axis is dramatically angled, then the way sunlight falls on its atmosphere and moons changes profoundly over time. The poles are not always cold, distant regions. Sometimes they are the bright focus of sunlight. Sometimes they are turned away into extended darkness. The planet's weather patterns can respond to these long cycles, shifting slowly, perhaps becoming more active during certain seasonal phases and quieter during others. Even when we cannot see the changes directly, we can imagine them as gradual adjustments, not sudden events. Uranus's atmosphere, with its subtle cloud patterns, can sometimes show bands and storms when observed in certain wavelengths and under certain conditions. These features may form and fade, appear and drift, like slow-moving patterns on a calm sea. The winds on Uranus can be strong, but the visual mood remains placid because the colors are gentle and the cloud tops can look smooth. The planet's face often resembles a softly shaded sphere, a quiet jewel. There is also Uranus's magnetic environment, another invisible architecture. Uranus has a magnetic field, but it is unusual in orientation and structure compared to some other planets. It can be tilted relative to the planet's rotation axis, and it may be offset from the center. This creates a magnetosphere that is complex and changing as the planet turns, like a lopsided bubble that wobbles gently. The solar wind meets this magnetic bubble and flows around it, and charged particles can be guided toward the planet's upper atmosphere, where auroras may glow. Even if we do not picture the colors, we can picture the process as calm, particles following invisible lines, arriving and releasing energy as soft light in the high, thin layers of a distant sky. From here, the idea of a sky becomes abstract. Uranus's upper atmosphere is not a place with a horizon you stand beneath. It is a vast envelope surrounding a planet, with layers that become denser as you go deeper. At high altitudes, the gases are thin and cold. Deeper down, pressure increases, and the atmosphere thickens, becoming a world of gradients and shifting states. The deeper you imagine going, the less the concept of a clear boundary makes sense. Uranus is a sphere of transitions. Our understanding of Uranus has come from distant observation and from a brief close look by a passing spacecraft. It was not a long, lingering visit. It was a flyby, a swift glance in the scale of a planet's life, yet it gathered images and measurements that transformed Uranus from a pale dot into a real place with rings, moons, a magnetic field, and weather. Since then, telescopes have continued the work, watching subtle changes, refining details, building a slow and steady picture of a planet that remains far away. There is a gentle lesson in that. Some places are known not by constant presence, but by careful moments of attention spaced across time. The solar system itself encourages that kind of patience. It does not reveal everything at once. It reveals in glimpses, in repeated passes, in the slow improvement of instruments, and the quiet persistence of curiosity. If you're still awake, that's perfectly all right. You can let the fact of Uranus be enough. A pale blue-green world, tilted in a remarkable way, wearing faint rings, surrounded by icy moons, travelling through long seasons in dim sunlight. And now, slowly, we begin to leave Uranus behind, not because it has been exhausted, but because our cruise has a gentle outward order, and the next destination waits farther still. As we move away, Uranus shrinks again into a bead of colour. Its rings become a thin suggestion, then vanish from view. Its moons fade into points, then into nothing distinguishable. Behind us, Saturn is now a distant sparkle. Jupiter is farther still, and the inner solar system is a cluster of lights too small to hold detail. Ahead is Neptune, deeper in the outer night, where sunlight is fainter still and the planet's blue becomes richer. Neptune is another ice giant, similar in category to Uranus, yet distinct in mood, with a deeper colour and a different expression of weather and wind. Beyond Neptune lies the Kuiper belt, where small, icy worlds circle in the dark, and where Pluto waits as one of the best-known travellers. For now, we are in the wide space between Uranus and Neptune, a long, quiet corridor with no walls, only darkness and steady starlight. The sun behind is now a bright point, still the centre, still the source. but so far away that its light feels almost like a distant candle in a large room. And in that gentle dimness, we continue outward, unhurried, calm, letting distance itself become soothing, and letting Neptune's far blue presence slowly grow ahead of us in the quiet, patient dark. At this distance, Neptune begins as a small, steady point with a hint of colour, as if someone has touched the blackness with a soft brush of blue. The colour deepens as we approach, becoming clearer and more certain, until Neptune resolves into a rounded world, calm and cool-toned, suspended in the thin sunlight of the outer solar system. The sun behind us is now a bright, distant presence, more like a luminous star than a large disk. Its light reaches Neptune gently, arriving with a softness that feels almost delicate. Yet even this delicate light is enough to reveal the planet's character. Neptune's blue is richer than Uranus's pale blue-green, a deeper shade that suggests a different balance in its upper atmosphere, a different way of filtering sunlight. Neptune belongs to the same broad family as Uranus, a giant planet with an interior likely rich in materials that can behave like fluids under pressure, wrapped in an atmosphere that becomes denser as you descend. It is not a place with a clear surface in the familiar sense. Instead, it is a world of layers, where what we see is the upper atmosphere, a moving skin of cloud and haze with deeper regions hidden below. As Neptune fills more of our view, we begin to see that it is not perfectly uniform. There are subtle bands and gentle variations in tone, faint streaks that curve around the planet, hinting at wind patterns and circulating air. Sometimes there are brighter cloud features that stand out against the blue, small pale marks that appear and shift as though the atmosphere is quietly sketching and erasing its own designs. These clouds can be made of different substances than the water clouds we know on Earth. In the cold outer regions, clouds can form from compounds that condense at low temperatures, arranging themselves into hazes and layers that reflect and absorb light in particular ways. We do not need to name every chemistry. It is enough to imagine a cold atmosphere where different vapors can become cloud, where ice crystals and aerosols can drift and gather, creating veils and bands that are both beautiful and subdued. Neptune's winds are known to be strong, yet the mood of the planet remains calm in our telling because the motion is so large-scale and so steady. This is not a fluttering storm on a small world. This is a planet-sized circulation, moving in broad patterns across a sphere. When a dark feature appears, like a large oval or patch, it is not a sign of danger. It is simply a region where the atmosphere differs, perhaps a large storm system, or a change in cloud depth that creates a darker window into lower layers. These features can come and go, evolving over time, like weather patterns on a vast distant sea. You can let the idea of wind become abstract here, a slow flow of atmosphere around a blue sphere, a steady turning of patterns that does not ask for your attention. Neptune spins, and that spin shapes its atmosphere, helping organize the winds into bands and jets. The turning is smooth and continuous, and it carries the planet's cloud features through light and shadow. In the outer solar system, even the concept of day and night feels quieter. Day still exists, night still exists, but the sunlight is faint enough that the contrast can feel gentler, and the planet's own glow, in certain kinds of observation, can sometimes be sensed as warmth radiating outward. Neptune is not alone. Like the other giant planets, it has a ring system, though it is far more subtle than Saturn's. Neptune's rings can be faint and dark, thin structures made of small particles. Some portions can appear as arcs, as though the ring is not evenly distributed all the way around. These arcs are part of Neptune's quiet strangeness, patterns held together by gravity and resonance, perhaps maintained by the influence of nearby moons that nudge particles into confined regions. Rings, even faint ones, add a gentle elegance to a planet. They are the solar system's way of drawing circles in space, delicate lines of motion that repeat endlessly. Each particle in a ring is a traveller, and together they form a band that looks like a calm signature. Neptune also has moons, and among them there is one that stands out immediately for its presence and its history. Triton approaches as a pale, substantial world, bright enough to catch the thin sunlight and return it softly. It is large compared to many other moons in the outer solar system, and it carries an unusual relationship with Neptune, moving in a direction that suggests it did not form in the same way as Neptune's other companions. This is a gentle way to say that Triton is widely thought to have been captured long ago, drawn into Neptune's gravity and settled into orbit over immense time. Capture is not an event we need to dramatize. We can simply imagine that in the early solar system, when small worlds and icy bodies were more plentiful in certain regions, gravitational encounters could lead to new arrangements. A body passing near Neptune could, under the right circumstances, become bound and eventually join the planet's system. Over time, the orbit could change, becoming more stable, more regular, more settled. Triton's surface is icy and bright, and it carries features that suggest it has been active in some way. Not active like a world with roaring volcanoes, but active in the slow, cold sense of ice geology. In very cold environments, ice can behave like rock, and under pressure it can flow, fracture, and reshape landscapes. Triton shows plains and ridges, and regions where the surface looks relatively young, as though older scars have been softened or covered. One of the most quietly fascinating aspects of Triton is the idea that it may have a layered interior, perhaps even pockets, where warmer conditions exist beneath the surface, guided by internal heat and tidal influences. Again, the theme returns softly. Gravity as a gentle sculptor, pulling and flexing, warming by repetition, creating the possibility of slow change beneath a crust of ice. Triton's atmosphere is extremely thin, but it exists, a fragile veil of gas that can come and go with seasons. In the dim sunlight so far from the sun, even small changes in illumination can matter, changing how volatile ices behave at the surface. A thin atmosphere can thicken slightly when certain ices sublimate into gas, and thin again when they freeze back down. It is a slow, subtle breathing, much gentler than weather on Earth, but still a kind of planetary rhythm. There have also been observations of material rising from Triton's surface, not in a fiery way, but in a cold, delicate release. You can imagine it as faint plumes or gentle jets driven by sunlight warming subsurface layers, creating pressure that finds a path outward. The result is not a violent blast, but a quiet venting, a soft exhale into space. In the cold outer regions, even a small amount of warmth can produce motion, and that motion, can leave traces across the surface in the form of dark streaks where particles settle. You do not need to picture this sharply. You can let it remain a soft image, a pale, icy plain under a dark sky, a distant sun, and a faint, slow drift of fine material carried by a thin breeze of an atmosphere that is barely there. As we drift around Triton and then return our attention to Neptune, we feel again the scale of the system. Neptune is large enough that its gravity shapes the space around it in a calm, authoritative way. Its moons keep their paths. Its rings maintain their faint arcs. The solar wind meets its magnetic environment, and fields guide particles in invisible loops. Neptune has a magnetic field, and like Uranus, it is complex in its orientation. This creates a magnetosphere that is not perfectly symmetrical, a bubble that shifts as the planet turns, interacting with the flow of charged particles from the Sun. This interaction can produce auroral activity, though often observed in wavelengths beyond ordinary human sight. Even without imagining color, you can imagine the idea as gentle, charged particles arriving along invisible paths and releasing energy as soft light high above the cloud tops. From this far out, the solar system feels quieter, not because it lacks activity, but because the timescales are longer and the distances are larger. Everything is still moving, everything is still responding to gravity, but the movement is slow enough that it can feel like stillness. If you're still awake, that's perfectly all right. You can let Neptune become a calm blue presence in your mind, a planet turning steadily in dim sunlight, with a pale moon circling quietly, and faint rings tracing delicate lines in the dark. Neptune's atmosphere, though visually subdued compared to Jupiter's bold stripes or Saturn's bright rings, holds its own kind of wonder. There is beauty in restraint. The blue sphere, the occasional pale cloud, the subtle banding, the sense of a deep, layered world beneath. When we talk about giant planets, it is easy to imagine only the cloud tops. But beneath, the atmosphere becomes denser, pressure rises, and the planet's materials change in ways that do not happen on small rocky worlds. Neptune is a realm of transitions, where gas thickens into fluid, where the familiar idea of a boundary fades, replaced by gradients. Neptune's year is long, its orbit wide. Seasons exist, but they unfold slowly. The sunlight that reaches Neptune changes its angle over time, and the atmosphere responds in gradual ways. Even if we cannot watch those changes directly as a quick story, we can understand them as part of the planet's deep rhythm, a slow shifting of illumination across a rotating sphere. Our knowledge of Neptune comes from a blend of distant observation and brief close visits by spacecraft. A flyby can offer a sudden clarity, revealing clouds and rings and moons in detail, but it is still only a moment compared to the planet's life. After such moments, telescopes continue the steady watch, measuring light and color, tracking cloud features, building understanding through patience. There is comfort in that method. The universe is not required to be known all at once. It can be known slowly, with careful attention, with repeated looks, with quiet persistence. Now gently, we begin to continue outward again. Neptune remains behind us for a while because it is large and bright in its own way, a blue beacon in the outer dark. Triton fades into a pale point and then becomes indistinguishable. The rings become too faint to see. Neptune itself shrinks gradually, becoming a small blue dot, and then just another light in the starry field. Ahead, the solar system changes character again. Beyond Neptune lies the Kuiper Belt, a region populated by many small icy bodies, remnants and neighbours from the outer reaches. This region is not a wall or a boundary, but a broad zone, much like the asteroid belt, though composed more of ice-rich bodies and living in colder, darker space. Here, small worlds travel in wide orbits, far from the sun's warmth, carrying ancient materials that have remained relatively unchanged for immense spans of time. As we glide toward this region, the sun becomes smaller still. It is still the same source of light, still the center of our system, but now it feels like a bright star in a deep night. Its light is faint enough that the idea of warmth becomes abstract. Yet it still casts shadows, still illuminates surfaces, still provides a direction, a sense of where the center lies. The space here feels especially open. The planets are behind us now. We are moving into the realm of smaller bodies, where the solar system's architecture becomes more subtle and more scattered. But scattered does not mean disorderly. These bodies still orbit. They still follow paths. They still return. The comfort of repetition remains. In the Kuiper Belt, an object can be large enough to become round, forming a dwarf planet. One of the best-known travelers here is Pluto, a small world with a heart-like brightness on its surface in certain images, and with a thin atmosphere that changes with its distance from the Sun. Pluto is not a planet in the classical list of major planets, but it is undeniably a world with landscapes and seasons and companions. As we approach the region where Pluto travels, we can hold it not as a singular destination that interrupts our cruise, but as a gentle point of interest among many. Pluto has a companion, Charon, large relative to Pluto itself, and together they orbit a shared point in space, a kind of balanced dance. Charon is darker and more muted, while Pluto shows more contrast, with bright icy plains and darker regions. Pluto's surface, where we have seen it, includes broad, smooth areas that suggest renewed terrain and mountains of water ice that rise above plains of frozen nitrogen. It is a world where familiar substances behave differently, where nitrogen and methane can freeze and form glaciers, where sunlight is so faint that even subtle seasonal changes can shift the balance of ice and vapor. Again, none of this needs urgency. It is simply the quiet wonder of a distant world still capable of change. Beyond Pluto, and alongside it, there are other Kuiper Belt objects, each with its own orbit, its own shape, its own mixture of ice and rock. Some are elongated, not fully rounded. Some may have moons. Some may have surfaces darkened by radiation and time, coated in complex organic compounds that build slowly as sunlight and cosmic rays alter ices at the surface. If your attention drifts here, it is natural. The Kuiper Belt is a place of faint light and quiet motion. It invites softness. You can let the details blur and simply imagine a wide region of small, cold worlds circling in the far outskirts, each one moving steadily, each one returning on a path that takes a very long time. And farther still, beyond the Kuiper Belt, the sun's influence extends outward in a vast bubble created by the solar wind. The solar wind continues to flow, thinning as it goes, meeting the interstellar medium at a distant boundary where the outward pressure of the sun's particles balances the pressure of space beyond. This boundary is not a hard wall. It is more like a transition, a region where one influence gives way to another. We do not need to reach it yet. We can simply sense that it exists ahead, an edge not of space itself, but of the sun's immediate touch. Even there, the sun's influence does not end abruptly. It fades, it tapers. It becomes a softer and softer presence. For now, we are still within the solar system's familiar family, just far from its bright hearth. We are drifting among small icy travelers, with Neptune behind, and the sun, a distant star, ahead and to the side, guiding our sense of direction. You can let the outer dark become a comfortable blanket. There is nothing to do, nothing to anticipate. Only slow orbits, quiet ice, faint light, and the steady understanding that even at the far edges, everything continues in calm motion, repeating its path through the patient, gentle night. Out here, the darkness does not feel empty. It feels spacious, as though space itself has expanded to make room for quiet. The sun's light still reaches us, but it arrives as a thin, steady glow, more delicate than it ever was, near the inner planets. It no longer floods everything with brilliance. Instead, it touches surfaces lightly, like a distant lamp shining across a large room. In this dim light, the Kuiper Belt becomes a place where motion is almost entirely measured in patience. The objects here do not hurry. Their orbits are wide arcs that take a long time to complete, and their seasons, when they have them, unfold slowly. Their surfaces hold frost and ice in many forms, and their landscapes can change in gentle ways when sunlight warms a region just enough to turn solid ice into vapor, and then back again when the light retreats. You can let the vastness do some of the work for you. Nothing here needs to be held tightly in mind. You can simply drift with the idea of small, distant worlds traveling in calm loops. Pluto, among these travelers, is a familiar name, and it carries a kind of quiet charm because it is both distant and detailed. When we imagine Pluto, it can be comforting to picture it not as a single point of trivia, but as a real place with texture and light. Its surface includes bright regions where frosts reflect the sun, and darker regions where more complex materials absorb it. In the thin sunlight, contrast becomes an important storyteller. A bright plain can glow softly, while darker terrain becomes a gentle, shadowed tone. Pluto's atmosphere, when it is present, is extremely thin. It can expand and contract as Pluto moves along its orbit, responding to sunlight with a slow rhythm. When sunlight strengthens, some surface ices can release gas, building a fragile veil around the planet. When sunlight weakens, that veil can thin again, with gases freezing back to the surface. This is not weather as we know it, with rushing winds and thick clouds. It is a delicate cycle of frost and vapor, a faint breathing that follows the slow turning of seasons. Pluto also has companions, and the largest, Charon, is almost a partner rather than a minor moon. Pluto and Charon revolve in a mutual dance, each influencing the other, their motion balanced. Charon's surface is darker and more muted, with its own patches of brightness, and together the pair offers a soothing reminder that gravity builds relationships at every scale. Not only a planet and a small moon, but two worlds sharing a steady bond. If we drift closer in imagination, Pluto's landscape becomes a quiet collage. There are broad plains that appear smooth, suggesting relatively young terrain. There are ridges and mountains made of hard water ice, rising above softer ices that can flow. It may seem surprising to call ice hard, but in the cold of the outer solar system, water ice behaves like rock, sturdy enough to form cliffs and peaks. Meanwhile, other ices, like frozen nitrogen or methane, can behave more like glaciers, slowly creeping across the ground. This is slow geology, gentle geology, a world reshaped in whispers rather than shouts. Where plains meet mountains, shadows stretch long in the low sun. The light here is always angled, always thin. It creates a calm palette, pale highlights and soft darkness, with a muted sense of colour. There can be a kind of twilight mood even at midday, because the sun is so small and far. Pluto's surface also carries patterns of frost and darker deposits, shaped by subtle winds in its thin atmosphere when it exists, and by seasonal exchange of ices. A world can change even in the deep cold, not quickly, but persistently. Over long time, frost can migrate. A region can brighten or darken. A plain can be resurfaced by slow flows. This is the kind of change that feels soothing to think about, because it is so gradual that it feels like stillness. And Pluto is not alone in being a distant, icy world with character. The Kuiper Belt contains many bodies, some smaller and irregular, some large enough to become round. A few have become well known, not because they are loud or dramatic, but because they expand our sense of what belongs in a solar system. Some of these distant objects are larger than Pluto, though they are far enough away that they remain faint to our telescopes. Their discovery came through careful searching, patient scanning of star fields, and noticing a tiny point of light that moved slightly from one night to the next. This is a gentle form of discovery, not a sudden reveal, but the quiet recognition of motion against a fixed background. When we speak of these distant worlds, it can be comforting to remember that they are not inventions of imagination. They are real objects, observed and tracked, their orbits calculated, their sizes estimated through the way they reflect light, and through the way they sometimes pass in front of stars, briefly dimming starlight in a measurable pattern. From such dimmings, and from careful study of reflected sunlight, we infer shape, size, and sometimes the presence of thin atmospheres or rings. It is slow knowledge, gathered like dew. One distant world is known for being especially far and faint, travelling on a wide, elongated path. It spends much of its time in deep cold, far from the sun's stronger light, and then, over a long cycle, it moves closer for a while before drifting outward again. When such an object nears the sun, even modestly, certain surface ices may warm enough to release gas, forming a temporary atmosphere or a faint haze. Then, as it recedes, that gas can freeze back down, returning the world to a quieter state. The story repeats on a timescale so long that it feels almost like a slow heartbeat. Other Kuiper Belt worlds have companions too. Small moons circle them, and in some cases, pairs of objects travel together as binaries, orbiting a shared centre. This is one of the Kuiper Belt's most soothing motifs, not just isolated stones in the dark, but partnerships, gentle gravitational handholds in an immense space. There are also objects with unusual shapes, not fully rounded, perhaps stretched or flattened by their rotation. In the outer cold, a fast-spinning body can take on a distinctive form, and collisions long ago can leave their marks in the way a world's mass is distributed. Some of these distant bodies appear to rotate quickly, and their light curves, the way they brighten and dim as they turn, suggests elongated forms. Even without picturing the exact shape, you can imagine the concept as calm, a distant world spinning steadily, showing different faces to the sun and reflecting slightly different amounts of light with each turn. The Kuiper Belt is also a place where surfaces can darken over time. Sunlight and energetic particles can slowly alter the chemistry of surface ices, building complex residues that absorb more light and take on deeper tones. This does not make the region sinister. It simply makes it ancient. Surfaces here have been exposed for a long time, and time leaves a patina. Some worlds become darker, some remain brighter, where fresh frost is renewed, and some carry a patchwork of both. If you're still awake, that's perfectly all right. You can let the Kuiper Belt become a soft concept rather than a collection of names. A wide ring of distant travelers, each one following an orbit, each one carrying frost, each one turning slowly, each one moving in the same patient style. And as we drift farther outward, we can notice how the sky itself feels different. The sun, though still bright, is now one bright point among many points. It still outshines the stars by far, but it no longer dominates the view as it once did. It feels more like a direction than a presence. Its light is a gentle guideline, telling us where inward is, where the center lies. This is also a good place to remember how spacecraft navigate, not by drifting without knowledge, but by careful tracking and gentle course adjustments. They listen to signals, they measure time delays, they compare expected positions to observed ones, and they remain oriented in the dark with quiet precision. Even far from Earth, even far from the Sun, the rules remain consistent. Motion can be predicted, orbits can be calculated. The solar system is a place of reliable mathematics beneath its beauty. And yet, in our cruise, we do not need to calculate. We can simply drift. We can let the distant objects pass at a comfortable pace, knowing that they will remain where they are meant to be. Beyond the main region of the Kuiper Belt, some objects travel even farther out, on paths that take them into an even quieter realm, where the sun's light is fainter still. These distant travelers are harder to see, and each new discovery in that far region has come through years of careful searching. Their existence hints that the solar system's structure extends outward in layers, from the inner rocky worlds to the gas giants, to the ice giants, to this realm of small, icy bodies, and beyond. And beyond all of these orbits, beyond the last large planet and the last familiar belt, the sun's influence continues not through light alone, but through its steady outflow of particles, the solar wind. The solar wind flows outward in all directions, forming a vast region around the sun, a kind of bubble in the interstellar medium. Inside this bubble, charged particles and magnetic fields shape a unique environment, a local neighborhood carved out by the sun's long, steady presence. This bubble has structure. It has boundaries of a sort, but not hard walls. It is more like a gradient, a place where the solar wind gradually slows and changes character as it meets the thin material between stars. Far from the sun, the solar wind becomes weaker and more spread out. It still moves, still carries the sun's magnetic influence, but it does so with less density. Eventually, there is a region where the solar wind slows as it encounters the pressure of the interstellar medium, becoming more compressed, changing from a freely flowing stream into a more complex boundary layer. This boundary region is calm in its own way, not a crash, but a meeting. Two influences touching and adjusting, like two slow currents meeting in a quiet sea. You can imagine that meeting gently. The sun's outward breath, thinning with distance, and the interstellar medium present everywhere, meeting and forming a soft edge of influence. The solar system is not fenced, it is not sealed. It is simply a place where the sun's presence is strong enough to shape the surrounding space, and where, far away, that presence becomes more subtle and eventually blends with the wider galaxy. If you're still awake, that's perfectly all right. You can let the idea of an edge become soft, not an ending, but a gradual fading, not a door closing, but a light growing faint. And in that faintness, we can return to the comfort of the small worlds around us. Kuiper belt objects continue their slow loops, each one keeping its distance, each one turning in the dark. Some have pale frosts that glimmer. Some have darker skins that absorb the thin sunlight. Some have moons that circle quietly. Some travel in pairs. Some carry the memory of impacts in gentle craters. And some have smoother plains where ices have shifted and flowed. Even the concept of a crater out here feels softened by time. A shallow bowl in ice, a rim catching a thin edge of light, a shadow that stretches long, then turns away as the world rotates. The shadow does not race. It glides like a slow hand on a quiet clock. And as we drift farther still, we begin to sense that our cruise is nearing the farthest familiar regions of the solar system's ordered journey, not in a way that demands conclusion, but in a way that invites deep calm. The sun is distant. The planets are behind. The Kuiper belt spreads around us as a sparse, ancient neighborhood, and ahead, the sun's influence continues to fade with grace, becoming more transparent, more subtle, more like a gentle memory. We can simply remain here for a while, floating through this outer quiet, letting the distant blue of Neptune be long gone behind us, letting the Kuiper belt's small icy travelers keep their steady arcs, and letting the dark, star-filled space cradle the mind in unhurried motion, as our cruise continues softly toward the sun's quiet, far-reaching edge. The edge is not a line you can point to with certainty from the outside. It is more like a slow thinning, a gradual change in the way space behaves as the sun's outward presence becomes less dominant and the wider galaxy begins to matter more. Here, in the far outskirts, the solar system feels less like a set of destinations and more like a gentle influence. The planets are long behind us. Even Pluto, for all its charm, is now one traveler among many, and the Kuiper belt itself becomes a broad, sparse region rather than a single place. Everything remains in orbit, everything remains orderly, but the order is quieter, stretched out over wider and wider arcs. Out here, sunlight is a thin thread. It still arrives in a straight line, still creates shadow and highlight, but it is soft enough that the idea of brightness becomes more like a gentle direction than a vivid sensation. The sun is still the center of our system, still the origin of the warmth that shaped the inner worlds. But from this distance, it feels like a bright star with a familiar name, a steady point you could hold between your thoughts without effort. The solar system's influence extends not only through gravity, which reaches forever, but also through the sun's continuous outflow of particles, the solar wind, and the magnetic field that is carried along with it. That outflow has been streaming outward for as long as the sun has been shining in this way, shaping a vast region of space, a kind of bubble or shelter, where the sun's presence has a particular character. Within this region, tiny charged particles move and swirl, guided by magnetic fields that are themselves shaped by the sun's rotation. The structure becomes a kind of invisible landscape, like currents in a very slow ocean. It is not something you see with your eyes, but it is something you can imagine as a gentle architecture, an organized softness, a way of defining here and there in the emptiness. As we drift farther outward, the solar wind becomes thinner and weaker. It continues, but it spreads, its particles more widely separated. The sun's magnetic influence is still present, but it is stretched and carried along, drawn into a long, flowing shape as the sun turns. The further out you go, the more you can sense that the sun's outward breath is meeting something else, something that does not come from the sun at all. Between the stars, there is material. Not dense, not crowded, but present. A thin mixture of gas and dust, drifting through the galaxy in its own slow streams. This is the interstellar medium, the subtle substance of the space between star systems. It is not an emptiness, it is a very quiet fullness. At the farthest outskirts of the sun's bubble, the solar wind begins to be challenged by this interstellar presence, not in a sudden clash, but in a gradual negotiation. The outward flow slows and changes. It becomes less like a free stream and more like a compressed region, where particles gather a little more densely and where the solar wind's character becomes more complex. You can imagine it like a gentle river meeting a broad, still sea. The river does not stop instantly. It spreads, it slows, it changes its shape. It creates a boundary region where the two waters mingle. The analogy is not perfect, but it captures the softness of the meeting. The solar system does not end with a wall. It fades into the galaxy through a layer of transition. Somewhere in this transition region, the solar wind slows significantly, changing state as it encounters the growing influence of interstellar space. Beyond that lies a broader zone where the slowed solar wind continues to flow outward more reluctantly, pressed and shaped by what surrounds it. And then, farther still, there is a boundary where the sun's bubble gives way, where the interstellar medium becomes the dominant environment. That boundary is often called the heliopause, the outer edge of the heliosphere, the region carved out by the solar wind. The name can sound technical, but the idea is simple and calm. It is the place where the sun's outward breath is balanced by the pressure of the wider galaxy. Even there, the transition is not absolute. The heliopause is a boundary of influence, not a fence. Fields can connect and reconnect. Particles can cross. The solar system's bubble is not sealed. It is a living boundary, soft and shifting, responding to changes in solar activity and to the conditions of the interstellar medium. This is one of the gentlest concepts in space, a boundary that is not a hard edge, but a conversation between flows. The sun breathes outward, the galaxy presses inward. The result is a shape, a subtle contour in space. We know about this region not because we have been there ourselves, but because we have sent a few patient travelers outward, spacecraft moving away from the sun over decades, carrying instruments that can sense the environment around them. These spacecraft do not arrive quickly. They do not rush. They drift outward with steady momentum, and as they go, they measure changes in particle density, magnetic fields, and the character of the solar wind. Over time, their measurements tell us where the sun's influence begins to soften and where the galaxy's presence begins to take over. It is a quiet kind of exploration, a slow listening, a gentle accumulation of evidence. The far edge of the solar system is not discovered with a dramatic arrival, but with a gradual recognition of change, as if the universe is whispering and the instruments are patient enough to hear it. You can let this far boundary become a soft idea, a faint veil at the outskirts, where the sun's touch becomes light and transparent. And it can be soothing to remember that even here, so far away, the same principles apply. Motion continues. Particles continue to stream. Magnetic fields continue to loop and stretch. Time continues at its steady pace. Nothing is required of you. In the deep outskirts, beyond the region where the Kuiper Belt objects travel, there may be other distant populations of icy bodies, perhaps forming a vast, sparse halo around the solar system. Some of these ideas belong to the realm of inference rather than direct observation, suggested by the paths of long-period comets and the way they sometimes arrive from far away, as if released from a distant reservoir. This hypothesized region is often called the Oort cloud, a broad shell of icy bodies that may extend far into the dark. We do not need to picture it as a crowded swarm. It would be extraordinarily sparse, with immense distances between objects. It would be more like a faint suggestion of structure, a wide scattering of icy remnants, each one orbiting the sun at a distance so great that the sun's light is minimal and the galaxy's influence becomes more noticeable. In such a region, the gravitational tug of passing stars and the gentle pull of the galaxy itself can slowly reshape orbits over immense times. Again, nothing sudden, nothing urgent, just a slow adjustment, like a barely perceptible shift in a long, slow dance. Comets, when they appear in the inner solar system, can be thought of as messengers from these distant places. They are icy bodies that spend most of their existence in cold darkness, then, through gentle gravitational nudges, find themselves on new paths that bring them closer to the sun. As they near the sun, their surface ices warm and release gas and dust, forming glowing comas and tails. That glow can seem dramatic in photographs, but at its heart, it is a simple, quiet process. Sunlight warming ice, ice becoming vapor, vapor carrying dust outward in a gentle flow. Even this can be held gently, without any tension. A comet is simply a traveler. It comes inward. It shines softly in the sun's light, and it continues onward, returning to the dark or leaving the system altogether depending on its path. The universe is full of travelers. From our cruising perspective at the outskirts, the solar system can feel like a layered home. At the center, the sun, steady and luminous. Close in, the rocky planets, small, dense worlds with sharp shadows and cratered faces. Beyond them, the asteroid belt, a spacious neighborhood of fragments and small worlds. Farther out, the giants, Jupiter and Saturn, with their moons and bands and rings. Beyond them, Uranus and Neptune, cool-toned and distant, with faint rings and icy companions. Beyond them, the Kuiper belt, with Pluto and countless other small icy bodies travelling in long loops. And beyond that, the fading reach of the solar wind, the gentle boundary where the sun's breath meets interstellar space. It is a structure built not for speed, but for repetition. Orbits repeat, seasons repeat, rotations repeat. Even when individual features change, the overall rhythm remains. You can let the repetition itself be soothing. The solar system is, in many ways, a set of circles within circles, each one calm and consistent. And you can let your mind rest on a simple image. The sun, now very far behind us, a bright point in a field of stars. Around it, invisible but real, the faint bubble of its influence. Within that bubble, countless travelers, planets and moons, asteroids and icy worlds, dust grains and particles, all moving in arcs that are steady enough to trust. Even the starlight out here feels different in mood, not because it has changed, but because our relationship to the sun has changed. When we were close to the sun, it dominated everything. Now the stars feel more present, more numerous, more like companions. They are still distant beyond comprehension, but their light fills the dark in a quiet way, making the universe feel softly populated. Some of those stars have their own planets, their own belts, their own distant icy halos. Many likely have their own boundaries where their stellar winds meet the interstellar medium, their own versions of a heliosphere, their own gentle edges. The galaxy may be filled with these bubbles of influence, overlapping in the mind, separated in reality, each one a quiet domain defined by a star's long, steady breath. But for now we remain with our own sun, our own system, and the calm fact that its influence does not end abruptly. It fades with grace, it grows thin, it blends into the wider space between stars. And if your thoughts begin to soften, that is welcome. You can let the idea of distance smooth out the details. You can let the names and features drift away. You can keep only the feeling of slow travel, of quiet motion, of gentle light. Out here, the solar system feels like a memory of warmth carried into a deep, cool night. The sun is still there, still shining, still the center of gravity that holds everything in its long embrace. But its light is faint enough that it no longer demands attention. It simply exists. And so we continue, just a little farther, into the softness of the boundary, where the solar wind becomes a whisper, where interstellar space begins to feel nearer, and where the last familiar travelers of our system keep moving in their patient arcs, unbothered, unhurried, and calm, beneath a sky full of steady stars. The sky here feels larger, not because it has grown, but because the sun has become so small in our view that it no longer fills the imagination. It is still bright, still unmistakable, but it rests among the stars as one brilliant point, a familiar beacon rather than a blazing disk. And in that change of perspective, the mind often relaxes. When a single light no longer dominates, everything else can feel quieter. In this far region, the solar system's outward flow becomes a gentle whisper. The solar wind is still there, still moving, still carrying the sun's magnetic imprint. But it is thinner now, more diffuse. as if its momentum has been stretched across too much space to remain strong. It meets the interstellar medium with a kind of calm resistance, the way a slow current meets another slow current. Neither has to win. They simply adjust. When we speak of the space between stars, it can be tempting to picture emptiness, but this region is better understood as a very thin material presence. There are atoms and molecules spread widely apart. There are dust grains, tiny specks of matter that drift through the galaxy. There are magnetic fields that thread through space, shaped by distant stars and by the larger structure of the Milky Way. There is a faint glow in some directions, the subtle light of interstellar gas, too dim for the unaided human eye, but present in the measurements of instruments that watch patiently. The sun's bubble sits within this larger medium like a warm breath held in the cold. It is not warm in the way a room is warm, but warm in the sense that the particles inside it carry energy from the sun's long activity. The boundary where these two environments meet can shift over time as the sun's output changes, swelling and easing like a slow lung. Yet the changes are gradual, and the overall shape remains a quiet fact. The sun influences a vast region, and then, far away, it shares the space with the wider galaxy. It can be soothing to consider how the solar system's story is a story of influence rather than ownership. The sun does not rule by force, it simply exists, shining, emitting particles, pulling with gravity, and the worlds around it respond. Far away, the galaxy exists too, with its own background influences, and the sun's sphere of effect becomes one layer in a larger tapestry. If you could see the heliosphere as a shape, it would not be a perfect sphere. It would be shaped by motion through the galaxy, by the direction of the interstellar flow, by magnetic pressures. It would have a front and a trailing region, like a slow-moving boat creating a wake. But even that image can be held gently. The important feeling is not the exact geometry. The feeling is that the sun's influence is extended, gradual, and soft at its edges. Beyond this boundary, the interstellar medium becomes the dominant environment. Yet the sun's gravity continues. Gravity does not stop at any border. It weakens with distance, but it reaches outward without end. The farther objects that orbit the sun do so because gravity remains quietly persistent. When we imagine the most distant travelers bound to the sun, we enter a region where the orbits are so wide and the periods so long that the concept of a year becomes almost meaningless in human terms. Objects there would drift in great loops, spending long ages in deep cold and dim light, turning slowly, perhaps tumbling gently, their surfaces coated in ancient frost, their shapes irregular, their histories mostly untouched. We do not need to name this region again. We can simply hold the idea of a distant halo of icy bodies, sparse and widely spaced, a kind of outer memory of the solar system's formation. In that halo, an object might spend most of its existence in quiet darkness, and then, through a gentle gravitational nudge from a passing star or from the galaxy's slow tide, it might find its orbit changed just enough to send it inward. The inward journey, too, would be slow. For a long time, it would still be far from the sun. The ice on its surface would remain frozen. The object would remain dark and quiet. Only when it drew closer, when the sun's light strengthened, would its surface begin to respond more actively, releasing gas and dust and forming a faint atmosphere around it. Even then, the process is simple and calm. Sunlight warms, ice becomes vapor, vapor carries dust. There is no need for drama. It is the same physics we have met again and again, repeated in different materials and at different distances. It can be comforting to think of the solar system as a place where the same basic rules create endless variety. Close to the sun, rock dominates, and sunlight is intense. Farther out, gases and ices become more important, and sunlight grows thin. Yet the rules remain the same. Gravity holds orbits, rotation shapes atmospheres, light reflects from surfaces, heat moves from warmer places to colder places. Over time, small effects add up, and landscapes change. If you're still awake, that's perfectly all right. You can let this be a quiet reminder that the universe is consistent. It does not surprise you by changing its fundamental nature. It only shows you more and more ways the same nature can express itself. From this far vantage, it can also be soothing to look inward in the mind, not to return physically, but to remember the path we travelled. The sun at the start, bright and close, with its flowing surface and steady outflow. Mercury, a world of sharp shadows and cratered stone. Venus, veiled in bright cloud, smooth and reflective. Earth, blue and white, with a thin atmosphere and a companion moon. Mars, rust-toned and open, with great quiet landscapes. The asteroid belt, spacious and scattered, with small worlds turning in the dark. Jupiter, vast and banded, with moons like small planets and slow storms that endure. Saturn, ringed and elegant, with bright arcs of ice and moons with hidden oceans and hazy skies. Uranus, pale and tilted, a quiet jewel with faint rings. Neptune, deep blue, with a pale companion and subtle rings. The Kuiper belt, full of distant travellers, with Pluto among them, a small world with frost, mountains of ice, and a thin, changing veil. Remembering them in this order can feel like a lullaby of places. Each one distinct, yet connected by the same central light, the same gravitational embrace. And now, at the far edge, that central light has become small, and the sequence of worlds has become a memory behind us. But the continuity remains. Everything we saw is still there, still moving. Mercury still turns under intense sunlight. Venus still wears its cloud cloak. Earth still spins with its soft weather. Mars still holds its deserts and its quiet canyons. Asteroids still orbit in their wide lanes. Jupiter still turns its bands and holds its moons in steady loops. Saturn's rings still circle, particle by particle, like a calm river of ice. Uranus still rolls through long seasons. Neptune still turns in deep blue. The Kuiper belt objects still follow their long paths. Nothing has stopped. Nothing has ended. It is all continuing, patiently. If your thoughts soften here, that is welcome. You can let the solar system become a slow, repeating pattern, like a familiar story told in a low voice. There is also a quiet beauty in how we came to know these places. Human eyes once looked up from Earth and saw wandering lights, the planets, moving among the fixed stars. Careful observers traced their paths, learned their rhythms, and slowly built a model of a system held together by gravity. Later, instruments extended sight into wavelengths beyond the visible. Spacecraft carried cameras and sensors outward, each mission adding a little more texture to the picture. Some traveled past planets in brief encounters, gathering moments of clarity. Others orbited and lingered, mapping surfaces and atmospheres in detail. Still others continued outward for decades, listening to the environment changing as they moved away from the sun. This method of knowing is steady and gentle. It does not require haste. It does not require certainty all at once. It is enough to observe, to measure, to compare, to return again and again, each time a little more clear. Even the far boundary we are contemplating is known this way, through careful sensing rather than direct sight. No one sees the heliopause with their eyes. It is inferred from changes in particle flows and magnetic fields, from a gradual shift in the character of space. It is a boundary in the language of instruments, a quiet transition translated into understanding. You can let that idea reassure you. Knowledge can be slow, understanding can be gradual. Nothing needs to be immediate. Out here, with the sun small, the stars can feel more present. They are still far beyond the scale of our cruise, but their steadiness can become a kind of comfort. Each star is its own sun, shining at its own distance. Some have planets, some may have belts of icy bodies, some may have rings of dust around young systems, some may have their own bubbles of stellar wind, meeting interstellar space. The galaxy can be imagined as filled with these quiet structures, each one a local neighborhood shaped by a star's long life. Yet our cruise remains rooted in our own system, and in that system's gentle order. The sun's light, even as a distant point, still feels like home. It is the same light that once filled our view and cast sharp shadows on Mercury's craters. The same light that reflected from Venus's clouds, that lit Earth's blue edge, that fell across Mars's deserts, that shone on Jupiter's bands and Saturn's rings, that touched Uranus's pale hue and Neptune's deep blue, that glimmered faintly on Pluto's frosts. Now it reaches us as a thin beam in the outer dark, and the continuity of it can feel soothing. We can linger a little longer in this quiet boundary region, letting the idea of the heliosphere settle, a vast, invisible shelter shaped by a star's steady breath, a place where outward flowing particles and fields create a distinct environment, and then, beyond, the wider space between stars, with its own thin material, its own subtle fields, its own slow tides. There is no need to think of the boundary as an end. It is more like a blending. The solar system blends into the galaxy. The sun's influence becomes one note in a larger chord. And in that blending, the feeling is gentle. The universe does not snap from one state to another. It eases. If you're still awake, that's perfectly all right. You can let that easing be your cue to soften too. You can let the details fade at the edges. You can let the names drift away. You can keep only the sensation of slow travel and steady light, of circles within circles, of calm motion in deep space. And as we continue to drift, with the sun behind us as a small, steady beacon, and with the faint interstellar presence all around, we remain in that quiet middle place where the solar system's breath grows thin and the galaxy's quiet becomes more noticeable, and where everything, from the smallest dust grain to the farthest icy traveller, continues its patient movement through the gentle, unhurried night. And in that unhurried night, it can feel natural to stop trying to picture the solar system as a map, and instead picture it as a mood of slow circles, of distant light, of steady returning. Out here, the darkness is not heavy. It is clean and open, like a calm ocean without waves. The sun is a bright point behind us, still the most luminous star in this part of the sky, but no longer demanding. It shines the way a porch light shines when you've stepped out into a quiet yard at night. It tells you where home is, without needing to illuminate everything. When your mind looks outward from this boundary region, the stars feel more present. They're not closer, not really, but their relative importance changes when the sun recedes. The sky becomes a tapestry again, not a stage lit by a single spotlight. Some stars appear in gentle groupings, patterns that human eyes have traced for a long time from Earth, turning random points into familiar shapes. From here, those patterns would look slightly different than they do from Earth, because our viewpoint has shifted, not dramatically, but enough to remind us that perspective is always part of what we see. The Milky Way, if you could see it in the darkest possible conditions, would be a pale band, a soft river of light across the sky, made of countless distant suns too faint to separate with the naked eye. It is a comforting sight because it suggests abundance without noise. Many lights, all steady, all distant, all quietly shining. And yet, even as the galaxy feels nearer in mood, the solar system remains a coherent home. Gravity still binds its members. Orbits still loop. Light still arrives. The sun's presence, though faint, is still organizing the space around us. We can drift for a while through the outer neighborhood, where the Kuiper Belt objects travel. It is a region that, like the asteroid belt, is best imagined as wide and sparse, not crowded. You could travel a long distance without passing near anything at all. But the objects are there, and their existence adds a gentle texture to the outskirts, like distant houses in a quiet rural landscape, each one far from the next, each one keeping its own lights low. Some of these worlds are brighter than others. Brightness, out here, often comes from frost. Pale ices can reflect sunlight efficiently, making a distant body stand out. Other worlds are darker, their surfaces coated with materials that absorb light. Over long time, sunlight and particles can alter surface ices, building complex residues that deepen the tone, like an old varnish that slowly darkens. A world can be born bright and become darker, or become bright again if fresh frost spreads across its surface. There is comfort in that slow cycle of change, brightening and dimming, not from day to night alone, but from seasons and surface migrations, from gradual shifts that take their time. A distant world can also be shaped by rotation. If it spins steadily, different regions come into view, and its light changes slightly as it turns. This is one of the quiet ways we learn about bodies too small or distant to resolve clearly. We watch their light, and we notice the gentle rise and fall as they rotate, as though they are breathing light in and out. From that light curve, we infer shape. We infer whether the body is round or slightly stretched. We infer whether it has bright patches or dark ones. It is a gentle kind of knowledge, gathered without touching, gathered from a careful watching. Some Kuiper Belt objects travel with companions so close and so well matched that they feel like partners. Two bodies orbiting one another slowly, steadily, keeping the same company for immense spans of time. The pair can circle a shared center, balanced and calm. It is an image that repeats in the solar system, moons around planets, binary worlds around one another, ring particles around a giant, dust around a small body, the same pattern again and again, circling, returning. There are also worlds with very distant companions, small moons far enough away to feel like separate points, even from nearby. Those moons can be irregular, shaped like pebbles, or rounder and smoother, depending on their size and history. Their orbits can be nearly circular or slightly elongated, but always the motion is steady. There is no hurry in an orbit. There is only repetition. You can let orbit become a soothing word, the way tide can be soothing. A tide comes in and a tide goes out. An orbit goes around and an orbit goes around again. Some distant bodies have been found to possess faint rings of their own, not bright like Saturn's, but subtle thin bands that circle small worlds, revealed by the brief dimming of starlight as the world passes in front of a star. That method is especially calm to imagine. A star shines steadily. A small world moves across it. The star dims slightly as the body blocks it. Then, a little before and a little after, faint dips can appear, indicating dust or ring material passing through the line of sight. From such tiny, patient measurements, a ring is inferred. A delicate structure, held by gravity, circling a small traveller in deep space. Rings are one of the solar system's gentlest signatures. They suggest order without rigidity, motion without urgency. They are made of many things moving together, each piece free in its own orbit, yet collectively forming a band that looks almost still. As we drift among these outer travellers, it can be soothing to think about how cold shapes become here. Not cold as a discomfort, but cold as a quiet preserver. In the far outskirts, sunlight is faint, and warmth is minimal. That means ices can remain stable. It means surfaces can preserve ancient features. It means materials can sit undisturbed for long spans, like artifacts stored in a deep, quiet archive. In such cold, even the idea of a landscape feels different. A cliff might be made of water ice as hard as rock. A plain might be made of nitrogen frost that can flow slowly, like a glacier, even though it is not water. A crater rim might hold its shape sharply because there is so little weathering to soften it. And yet, even here, there can be change. Frost can migrate when a season brings a little more light. A thin atmosphere can appear and fade as ices release gas and then recapture it. A surface can brighten in one region and darken in another, like a slow painting being altered by a very patient hand. The sun is still the hand, in a sense. Not pushing, not forcing, but providing just enough energy for subtle processes to continue. If you let your attention rest on the sun's light here, you might notice the way it becomes less of a flood and more of a direction. Light in the outer solar system is like a calm compass. It defines what is bright-facing and what is shadow-facing. It creates a gentle division across a world. And because the light is thin, the division can feel soft, like the edge of twilight. On a small, icy body far from the sun, twilight can linger as a feeling, even when the sun is up. The shadows are long, highlights are pale, contrast becomes gentle. It is an environment that, in imagination, can feel naturally sleep-friendly. Not because it is blank, but because it is muted, and because the changes are slow. We can drift a little closer again to Pluto's neighbourhood, not to repeat facts, but to linger in atmosphere. Pluto and Charon turning around each other, a quiet pair. a bright plane catching faint light, darker regions absorbing it, a thin veil of gas appearing when conditions allow, then settling back down as frost. This is the kind of world that teaches you to think in slow cycles. And beyond Pluto, other travelers continue. Some are larger, some are smaller. Some have longer, more elongated paths. Some stay closer to the Kuiper Belt's main band. Each path is a signature, an individual handwriting of gravity and history. It can be soothing to imagine these orbits as tracks drawn in 3 dimensions, invisible lines curving through space. If you could see them all at once, they would form a complex sculpture of loops and arcs, all centered on the same distant sun, all nested within one another, each one repeating. The solar system would look like a calm piece of kinetic art, except the motion is slow enough that it would feel almost still. And if your thoughts begin to drift toward the idea of outside, you can let them drift. The solar system's bubble, the heliosphere, is one kind of boundary, but it is not the only boundary that matters. There is also the boundary of familiarity, the point where the names and images we carry from childhood become less common, where we move from planets that feel like characters to objects that feel like quiet, distant stones. Yet even unfamiliar objects can become soothing when you remember that they are still part of the same gentle physics. They still orbit, they still rotate, they still catch light and cast shadow, they still respond to the slow tug of gravity. The interstellar medium around us is also calm. It is thin, not empty. It has its own subtle flow relative to the sun's motion through the galaxy. That motion shapes the heliosphere, giving it a front and a tail. You can imagine the sun's bubble like a soft, extended shape, with the sun nearer one end, and a trailing region stretching behind like a long, faint wake. This wake is not a place of turbulence in our telling. It is simply a region where the sun's influence is carried along, where particles and fields stretch out and gradually mingle with the galaxy's background. It is part of the quiet blending that happens when one steady presence moves through another steady presence. If you're still awake, that's perfectly all right. You can let blending be a comfortable word too. Nothing sharp, nothing sudden, just gradual change. In this boundary region, the idea of sound does not apply the way it does on Earth. Space is silent in the sense that there is no air to carry sound waves in the usual way. Yet instruments can translate particle interactions and electromagnetic signals into audible representations for human interpretation. That translation can make space seem like it has voices and tones. In reality, those are human choices, ways of turning invisible data into something our senses can grasp. The underlying reality remains quiet, a dance of particles and fields, a slow conversation carried out without noise. And the quiet is, perhaps, the greatest gift of this far journey. Close to Earth, our lives are full of signals, reminders, schedules, demands. Out here, there is only the slow certainty of motion. A planet turns, a moon circles, a small body drifts on its long orbit, a field line stretches and relaxes, a boundary shifts slightly. Everything is patient. We can let that patience settle into the mind, like a warm blanket that does not weigh you down. The mind can mirror what it observes. It can become less urgent. It can become more steady. And perhaps to keep the journey gentle and ordered even now, You can picture the solar system like a set of concentric stories, each one farther out, each one quieter. The bright inner worlds with sharp shadows, the belt of fragments, the giants with their broad atmospheres and deep gravities, the ringed elegance of Saturn, the pale tilt of Uranus, the deep blue calm of Neptune, the scattered icy travellers of the Kuiper belt. And now, the soft boundary where the sun's breath fades into the galaxy. The story does not end here. It simply becomes more spacious. And in that spaciousness, we can continue to drift without a destination, letting the sun remain a distant point behind us, letting the stars remain steady ahead, and letting the outer solar system's small icy worlds keep their gentle arcs as everything in this quiet region continues to move in calm, repeating patterns through the deep, unhurried dark. Through that dark, the steady patterns continue, and it can be comforting to realize that the darkness is not a place where things stop. It is simply the background against which slow motion becomes visible. The sun behind us remains the brightest point in this part of the sky, and even here it gives a sense of orientation. Inward is the direction of that steady light. Outward is the direction where that light grows thinner still, and where the stars begin to feel like they belong to the foreground of your attention. If you're still awake, that's perfectly all right. You can let the details soften. You can keep only the feeling of slow travel and quiet repetition. In the outskirts, repetition is everywhere. A distant icy body turns, showing a slightly different face to the sun, then returning. A binary pair circles its shared balance point, then circles again. A ring, faint and narrow, keeps its particles in a narrow lane, each fragment completing an orbit and beginning another without ever needing to stop. Even the solar wind, though it thins and changes, continues to flow outward as a kind of long, quiet exhale, shaped by the sun's rotation and by the interstellar medium's gentle pressure. There is a kind of calm trust built into these motions. They are not improvised. They do not depend on constant correction. They follow from the way matter moves in gravity and the way energy spreads in space. When you watch the heavens, you are watching reliability. That reliability is part of why astronomy has always felt like a steadying science. The sky, despite all its variety, behaves with patience. The wanderers return, the patterns repeat, the changes are gradual enough to observe across generations. Even now, far from the inner worlds, that same quality remains. The solar system is still doing what it does, quietly, without interruption. Out here, the sun's bubble of influence becomes more like a subtle weather boundary. Not weather of air and cloud, but weather of particles and fields. In the inner system, the solar wind is a steady stream that can be felt in how it shapes comet tails and in how it interacts with planetary magnetic fields. In the outer system, it becomes a thinner presence, and near the boundary, it becomes a kind of softened frontier where the sun's outward flow meets the gentle resistance of interstellar space. The interstellar medium is not something you bump into. It is too thin for that. But it is enough to matter over great distance, enough to press back, enough to shape a boundary. And because everything here is so gradual, the meeting does not feel like impact. It feels like a slow rounding of a corner, like a current turning and dispersing rather than breaking. You can simply imagine a vast, invisible contour in space, like the shoreline of an ocean seen from high above, not sharp, not jagged, but softened by distance. When the mind turns inward again, the solar system's earlier sights can return like gentle postcards. You might see Saturn's rings as a quiet arc, bright and clean against black. You might see Jupiter's banded clouds as smooth stripes, a painted globe with slow storms embedded like calm eddies. You might see Mars as a rust-toned desert with long shadows and wide open space. You might see Earth as blue and white, with a thin line of atmosphere like a soft halo. You might see Venus as a bright pearl, hidden under cloud. You might see Mercury as a cratered stone under intense light. And perhaps you notice how each of these images has the same basic ingredients: light, shadow, motion, time. Light arrives from the sun. Shadow is cast by round bodies turning. Motion is the steady travel of orbit and rotation. Time is the patient keeper of change, smoothing edges, shifting frost, building dunes, drawing ring patterns, renewing surfaces. Out here, time feels especially present because distance makes everything slower. Seasons stretch. Orbits widen. The return of a distant object feels like a long thought finally completing itself, yet it still completes. That is the quiet marvel. A distant icy world may carry a bright patch of frost for a while, then slowly lose it as the sun's angle changes, then regain it as the balance of cold returns. A thin atmosphere may appear as a faint veil when conditions allow, then settle back onto the surface in silence. A glacier of exotic ice may creep across a plain so slowly that it seems still, yet, given enough time, it reshapes the landscape. Even the smallest effects matter out here, because nothing interrupts them. There is no thick air to erode cliffs quickly, no flowing water to hurry the carving of valleys, no forests to grow and fall. The changes are quieter, but they are steady, and steadiness can be more powerful than speed. There is also the slow influence of sunlight itself, not only as warmth, but as a gentle pressure. Light carries momentum. It is small, almost unimaginable in daily life, but over long time, it can nudge dust grains. It can shift the paths of tiny particles. It can, little by little, change the distribution of the finest material in a ring or in a dust cloud. The solar system is a place where tiny pushes can matter if given enough patience. This is not a demanding thought. It is a soothing one. It says that the universe does not need forceful events to create change. It can use gentle influences, repeated quietly, to shape structure. If you're still awake, that's perfectly all right. You can let that gentleness be a comfort. The universe is not only about bright flashes and sudden turns, it is also about soft nudges and long, slow arcs. In the outermost regions, the direction of inward and outward becomes almost like a breathing exercise, though we do not need to treat it that way. Inward is toward warmth and brightness, toward the familiar rhythm of short seasons and close orbits. Outward is toward coolness and faint light, toward wide circles and long cycles. Neither direction is better. Each has its own mood. Each has its own quiet beauty. Our cruise can remain outward in mood, even if our thoughts drift inward for a moment. We are still in the far outskirts, still near the region where the sun's particle influence begins to blend with interstellar space. The sun remains behind us as a steady point, and ahead the stars hold their positions with calm permanence. Sometimes it helps to picture the solar system's shape as a family of planes and tilts. Most of the planets orbit roughly within the same broad flatness, like a disk. The rings of the giant planets, too, lie near their equators, reinforcing that disk-like geometry. The Kuiper belt also has a broad disk-like arrangement, though with a thickness to it, a gentle spread. Yet there are always exceptions: bodies with tilted paths, objects on unusual inclinations, travelers whose orbits are angled relative to the main plane. These variations add softness to the system, like a piece of fabric that is mostly flat but has gentle folds. The folds are not mistakes, they are histories. They suggest that long ago, gravity's interactions, collisions and captures gave some bodies their unusual paths. Over time, those paths persisted. The solar system remembers its past in the angles of its orbits, in the tilt of Uranus, in the captured motion of Triton, in the scattered inclinations of distant icy bodies. Remembering that can be calming too, not because we must reconstruct every event, but because it reinforces the sense that what we see now is the result of long, gradual shaping. Even when something unusual appears, it is still part of a quiet, consistent story. Out here, comets can return to mind in a gentle way, not as dramatic visitors, but as distant residents. A comet spends most of its time far away, cold and quiet, a small nucleus coated in ancient ice. When it travels inward, sunlight awakens it slowly, gas releases, dust lifts, a faint envelope forms around it. A tail can stream away, guided by the solar wind and by sunlight pressure, always pointing roughly away from the sun. Then, as the comet travels outward again, the activity fades. The comet returns to quiet cold. In that cycle there is something soothingly seasonal. A long sleep, a brief brightening, a return to sleep. The universe has its own versions of rest and activity, scaled out over immense time. If you're still awake, that's perfectly all right. You can let that be a calm metaphor without needing to hold it too closely. Near the sun's far boundary, the solar wind's guidance becomes less confident. It slows, it turns, it changes. The interstellar medium presses in with its own thin flow. Magnetic fields from the sun and the galaxy can meet and interact, creating regions where particles behave differently, where boundaries are felt not as walls, but as changes in texture. Instruments can notice these changes as shifts in particle counts and in the orientation of magnetic fields. To the eye, the space looks the same. To a sensor, the space speaks in subtle differences. This is a quiet reminder that the universe has layers we cannot see directly. Even on Earth, so much of reality is invisible: radio waves, magnetic fields, microscopic particles. In space, the invisibilities are even more central, yet they are not mysterious in a fearful way. They are simply parts of nature that require different senses to perceive. And when we build those senses into instruments, we extend our awareness outward with patience and care. It is also a good moment to remember that the planets we visited inward are not only physical places, they are also milestones in human curiosity. Each world marked a step in our ability to observe and to travel. Telescopes saw them first as points of light, then as disks, then as places with features. Spacecraft turned points into landscapes. Mapping turned glimpses into understanding. And all of it was done in an unhurried way, across decades, across lifetimes, with no single moment required to hold all knowledge at once. If you're still awake, that's perfectly all right. You can let that reassure you too. You do not need to hold everything. Understanding can come in gentle pieces. Out here, our cruise can settle into a kind of quiet hovering. Not physically hovering in the sense of resisting gravity, but hovering in the sense that the mind can pause in the outer dark. The story can slow. The images can become simpler. The sun behind, the stars ahead, the faint presence of interstellar material around, the soft concept of the sun's bubble fading into the galaxy. In that simplicity, the mind often finds rest. Sometimes, a useful way to picture the solar system from far away is to imagine the sun as a lantern at the center of a very large clearing. Close to the lantern, the ground is brightly lit, and the details are sharp. Farther away, the light becomes dimmer, and the shadows soften. Beyond a certain distance, the lantern's light still reaches, but it no longer defines the entire scene. The stars, the background, the larger environment begin to matter more. This does not make the lantern less important, it simply places it into a wider context. The sun is our star, and it has shaped our worlds, but it is also part of a galaxy filled with stars. Its bubble of influence is vast, but it is one bubble among many, each defined by a star's own steady outflow and gravity. That thought can be both humbling and soothing. It suggests that there are countless places where similar quiet physics is at work. Countless worlds turning, countless moons circling, countless rings tracing arcs, countless small icy travelers moving in long loops, and beyond them, countless boundaries where stellar winds blend into interstellar space. It is a universe built from repetition, and repetition can be restful. If you're still awake, that's perfectly all right. You can let the repetition do the calming for you. You can let the words become like the slow movement of distant orbits, circling back to familiar ideas, then drifting forward again. We can remain a little longer in this outer quiet, letting the solar system feel complete behind us, and letting the galaxy feel gently present around us. The sun is still shining. The planets are still turning. The belts are still populated by their travelers. The far boundary is still blending, still shifting softly, still doing what it has always done. And in that steady continuation, there is nothing you need to solve, nothing you need to remember perfectly, nothing you need to anticipate. There is only the calm fact of motion, the soft light of a distant sun, and the patient, repeating patterns of space carrying everything along, quietly, through the deep and gentle night. Night, here, has a clean kind of softness, as though it has been carefully brushed smooth. The stars remain steady, and the sun, though distant, still offers a gentle anchor, a bright point that makes the rest of the sky feel even calmer by comparison. As we drift, it can be soothing to notice how little changes from moment to moment. There is no wind against a face, no sound in the air, no sudden shift in temperature that you can feel. The changes are all in the slow turning of perspective, the tiny repositioning of light, the gradual unfolding of distance. The solar system, seen from its far outskirts, can be imagined as a long, slow melody. The opening notes are bright and close. The middle notes broaden into wide chords. The final notes become sparse and airy, like the last faint vibrations of a string. Yet the melody remains coherent because the same source holds it together, the same central light, the same gravity, the same quiet rules. Light is one of those rules. It leaves the sun and travels outward, never tiring, never slowing, simply spreading. Close in, it is intense. Far out, it is delicate. But it is always the same light, and it always tells the same story. It shows you which side of a world is facing the sun. It shows you the curve of a planet by the way it shades from bright to dark. It shows you texture in a crater rim, or in a ring plane, or in a cloud band, by the way it creates highlights and shadows. Out here, with the sun so small, light feels like a gentle suggestion. You can imagine a faint sheen on a distant icy surface, or a thin line of brightness along a ridge. You can imagine a long shadow stretching across a plain and then sliding slowly as the world turns. The shadow does not hurry. It glides, and then it returns. Rotation is another rule, another steady comfort. Worlds turn because they were given spin, and spin persists. A turning world is a kind of lullaby all by itself. It repeats. It brings daylight and darkness in a predictable rhythm. Even when the day is long or short, even when the sun is faint, the turning continues. Orbit is the larger turning. A world goes around the sun, and it goes around again. The orbit is not a track carved into space, but it might as well be because it repeats so faithfully. And in the outer regions, where orbits are wide, the repetition feels even more like a deep, slow breath. You can let your mind rest on that repetition, like watching a slow wheel turn. It turns, and it turns, and it turns, and nothing needs to be done about it. If you're still awake, that's perfectly all right. You can simply keep traveling. Even the smallest things travel in repetition. Dust grains can orbit too, influenced by gravity and by light. Tiny particles released from collisions or gentle outgassing can form faint clouds that drift and spread. Over long times, dust can migrate, guided by subtle forces, leaving behind a fine haze in certain regions and a cleaner emptiness in others. These motions are not visible in the way a planet is visible, but they are part of the same quiet system. When you imagine the solar system from this far vantage, it can feel less like a set of separate places and more like one connected structure. The sun at the center, the planets nested outward, the belts as wide regions of small travelers, the space between, filled with light and particles and fields, the boundaries, soft and gradual, where one influence fades into another. And because it is connected, the memory of our journey can return in a very gentle way, like a series of calm images drifting past. You might see the sun first, not as heat or glare, but as texture, a surface in constant motion, bright and flowing, with a steady outpouring that extends far beyond the planets. You might remember the feeling of beginning near that brightness and then stepping away from it slowly, letting it become less intense. Then Mercury, a quiet stone under strong light, where craters hold long shadows and the horizon is sharp. Then Venus, bright and veiled, a world of clouds that reflect sunlight and hide their depths. Then Earth, briefly, a familiar blue and white sphere, calm from afar, its atmosphere a thin line, its moon a gentle companion. Then Mars, rust-toned and open, its landscapes wide and still, with two small moons gliding close by like patient pebbles. Then the asteroid belt, spacious and scattered, where small worlds turn slowly and nothing feels crowded. Ceres, round and quiet, with hints of bright salts. Vesta, brighter and scarred, holding its history in a cratered face. And beyond, the gradual arrival of Jupiter, immense and banded, with a family of moons that feel like a second solar system within the first. Jupiter's stripes, its slow storms, its steady turning. Io painted in warm tones, Europa etched with fine lines, Ganymede grooved and layered, Callisto calm and cratered. Rings faint and dusty, a subtle halo. A magnetic realm that stretches far, invisible and structured. Then Saturn, ringed and elegant, the calm geometry of countless orbiting particles. The rings bright in thin light, with gaps and divisions drawn by gravity. Titan under a hazy veil, with quiet weather in a cold form. Enceladus, bright and icy, gently releasing tiny grains that join a ring. Shadows of rings on cloud tops, and the planet's shadow on the rings, slow-moving shapes that make space feel three-dimensional. Then Uranus, pale blue-green, subtly banded, turning in a remarkable tilt, seasons unfolding like long, slow turns of a page, faint rings like thin lines of charcoal, moons with fractured faces and quiet scars. A magnetic field that sits oddly, creating a lopsided bubble that wobbles gently with the planet's turn. Then Neptune, deep blue, with subtle clouds and occasional pale streaks. Triton, bright and icy, a companion with a quiet history, its thin atmosphere and possible plumes a soft exhale into space. Faint rings with arcs, delicate and understated. Then the Kuiper Belt, a region of small, icy travelers, wide and sparse, with Pluto as a familiar world among many. Frost and shadow, mountains of water ice, plains of softer ices that can creep like glaciers. A thin atmosphere that appears and fades with seasons. Charon close and steady, a partner in a balanced dance. All of this can be remembered without effort, like a slow parade of images, each one calm, each one unhurried, each one connected. Out here, beyond the Kuiper Belt's main neighborhood, the story becomes more about environment than about landmarks. The sun's outflow grows thin, the interstellar medium grows more influential, boundaries become gradients. Change becomes texture rather than event. The concept of the heliosphere can be held like a soft dome of influence. Within it, the solar wind and the sun's magnetic field shape the local space. Outside it, the interstellar medium has its own particles and fields, its own slow flows. The transition between the two is not a door, it is a veil. You might imagine passing through that veil as passing from one kind of quiet to another kind of quiet. Inside, the sun's breath is noticeable, even when faint. Outside, the galaxy's background becomes more present. Yet both are gentle, both are thin, both are slow. And even as the environment changes, the solar system's gravity continues to hold its distant travelers. Gravity does not stop at the edge of the sun's particle influence. It stretches outward, diminishing with distance but never ending. The most distant bound objects, if they exist in a vast halo, would still respond to the sun's pull, still loop around it on paths that take immense time. Those orbits are so wide that they feel almost like a meditation on patience. A world far out would take a long time to complete a single loop, spending ages in the cold dark, then very gradually coming inward, then very gradually receding again. The journey would be its whole existence, the orbit its whole story. And that can be soothing to consider. existence as a gentle loop, not a straight line toward an ending, but a circle that returns. If you're still awake, that's perfectly all right. You can let the circle be a comfort. The galaxy itself has circles too. Our sun orbits the center of the Milky Way, traveling through a vast spiral structure, accompanied by countless other stars, each with its own motion. That larger orbit is also slow, also patient. It is a reminder that even the things that seem fixed are moving, and they move in steady patterns. When you imagine the sun moving through the galaxy, shaping its heliosphere as it goes, you can picture the sun's bubble as a soft shape gliding through a thin medium, like a lantern moving through a faint mist. The mist is the interstellar medium. The lantern is the sun's steady outflow and magnetic presence. The shape of that bubble is gently sculpted by motion and pressure, with a forward-facing region and a trailing region, a wake that extends, thinning into the wider space. The wake is not a place of chaos in this telling. It is simply a gradual extension of influence, fading with distance, a long, faint tail of particle environment that becomes less distinct as it blends with the interstellar background. And in that blending, there is a sense of softness. The universe is full of borders that are not sharp. Atmospheres fade, magnetic fields weaken, light spreads, influence tapers. Everything seems to prefer gradual transitions. Even on Earth, the sky does not end abruptly. It fades upward into thinner air and then into space. Even the ocean shore is often a gradient, wet sand becoming dry sand, foam dissolving into water. The universe repeats this preference for gradients at every scale. Here, at the far outskirts, where the sun is a bright point and the stars feel close in mood, you might notice how easily the mind can release its grip. The mind often tightens around urgency, around schedules, around unfinished tasks. But there is no urgency in an orbit. There is no schedule in the way a planet turns. There is only steady motion, and the steady motion continues whether it is watched or not. That can be a quiet permission. You do not need to manage the universe. You do not need to hold it up. It moves on its own, with calm reliability. And yet the details remain available in the background, like distant stars. If you want them, they are there. Rings and moons, bands and storms, frost and shadow, tilted axes and long seasons. The gentle mechanics of gravity shaping everything into loops and arcs. Sometimes it is soothing to return to one simple image. Saturn's rings, seen from a distance. A bright band around a pale planet suspended in black, tilted slightly, a perfect curve. Within that curve, countless individual orbits, each particle moving, each particle repeating, each particle part of the whole. It is complexity made restful by repetition. Or another simple image, Jupiter's slow storm, a large oval turning within a striped atmosphere, enduring through time, changing gradually like a familiar mark on a familiar face. It is weather on a scale that makes weather feel patient. Or another, Europa's pale surface with dark lines crossing it, suggesting hidden movement beneath. Not loud, not visible, but implied, like a quiet secret. Or another, Titan under haze, with dim light and a sense of soft weather, lakes and rivers of a different kind, an echo of Earth's patterns in a cold, distant key. Or another, Neptune's deep blue, a calm sphere in faint sunlight, with Triton circling, pale and steady. or Pluto's frost and mountains, a small world with real terrain in a place once imagined as only emptiness. You can pick one and let it rest with you, letting it become a quiet backdrop for thought, or a quiet replacement for thought. If you're still awake, that's perfectly all right. You can simply stay on this gentle cruise, drifting at the edge of the sun's influence, with the solar system behind and around you, and the wider galaxy quietly present, while everything continues in its calm, repeating motion through the deep, open night. And in that open night, the mind often begins to notice smaller things, not because they are closer, but because there is so much room for attention to settle. A single point of light can feel like a gentle companion. A faint curve of reflected sunlight can feel like a quiet landmark. Even the idea of a distant orbit, unseen and yet certain, can feel steady enough to lean on. The sun remains behind us as a bright point, a familiar anchor that does not need to dominate. It is simply there, constant, patient, shining without expectation. The stars, too, are constant. They do not flicker here. They do not change with the air. They remain steady, as if the universe has made a promise to keep them in place for as long as we need to look at them. Out here, distance itself becomes a soothing subject. Distance is not emptiness. It is space for motion. It is room for orbits. It is a wide margin where things can exist without crowding one another. In the inner solar system, the sun's presence is immediate, and the planets can feel like neighbors. In the outer regions, the same system becomes more like a quiet countryside, with long stretches between homes and a night sky that feels larger because there are fewer bright lights nearby. And still, the solar system remains a single family, held together by gravity's gentle reach. Gravity is not a rope that can snap. It is a steady invitation, a pull that weakens with distance, but never truly ends. It keeps the planets on their paths. It keeps moons circling their planets. It shapes rings into thin planes. It gathers dust into lanes and belts. It defines the calm architecture of everything we have visited. That architecture is not rigid, it is flexible, shaped by small changes over time. A moon can shift its orbit slightly as it exchanges energy through tides. A ring can spread and thin as particles collide gently and trade momentum. A small icy world can be nudged by a larger neighbor into a slightly different path. But the changes are almost always gradual. The universe, at this scale, prefers patient adjustments. If you're still awake, that's perfectly all right. Nothing here requires focus. You can simply rest in the feeling of slow, reliable movement. There is a quiet wonder in how often the solar system builds beauty from simple rules. A planet turns, and its atmosphere organizes into bands. A moon orbits, and its gravity carves a gap in a ring. Ice warms slightly, and a thin atmosphere appears, then fades. Dust drifts, and a faint halo forms. Each process is straightforward, and yet the result can be unexpectedly graceful. Rings are perhaps the clearest example of this grace. When you picture Saturn's rings again, you can imagine not only the bright arc, but also the invisible choreography that maintains it. Particles orbit closer in, moving a little faster. Particles farther out move a little slower. This difference is not a conflict. It is a natural gradient, like the way water flows differently near the center of a stream than near its edge. Within that gradient, small moons keep watch, shaping edges, holding arcs in place, setting up resonances that create waves. The result is a pattern that looks serene because it is stable, and stable because it is constantly in motion. A similar serenity exists in Jupiter's system. When you imagine the Galilean moons again, you can picture them as a calm procession, each one in a steady lane. Their gravitational relationships can create subtle rhythms, a kind of timing that keeps their orbits from drifting too far out of harmony. Those relationships can also create internal warmth through tides, and that warmth can keep an ocean liquid beneath ice or renew a surface. It is a long chain of cause and effect, each link gentle, each link reliable. Farther out, Uranus and Neptune carry their own quiet rhythms. Their colours, pale and deep, are reminders that sunlight can be filtered and reshaped by an atmosphere, that a planet's appearance is the result of tiny interactions between photons and molecules. Uranus, with its unusual tilt, turns a familiar concept into something quietly surprising. A season can be a long, sustained illumination of a pole, followed by a long twilight. Neptune, with its deeper blue, offers a different mood, like a darker velvet cloth laid under the stars. Beyond them, the Kuiper Belt becomes a region where the solar system's material feels like it has been stored in a cold, silent cabinet. It is not untouched, but it is preserved. The sunlight is faint. The pace of change is slow. The objects carry frost and shadow, and some carry thin atmospheres that come and go with the long seasons of their orbits. If you're still awake, that's perfectly all right. You can let these images become softer. You can keep only one or two, or none at all, and simply drift. Sometimes it can help to imagine what the sunlight looks like on a small, distant world. Not the brightness itself, but the quality of it. The sun is small. It feels more like a bright star than a lamp. The light still casts shadows, but the whole scene is dimmer, and so the shadows feel less like dark pits and more like gentle gradients. A crater rim might catch a thin highlight, a clean, bright edge, while the crater floor fades into soft darkness. A ridge might glow faintly along its crest. A plain of frost might shimmer with a subdued sheen, as if the surface has been dusted with powdered glass. In such a landscape, movement is minimal. There is no wind in the usual sense, unless a very thin atmosphere briefly stirs. There is no rainfall, no rushing water, no leaves moving. There is only the slow turn of the world, and perhaps the slow creep of ice over long time, like a glacier moving so gradually that it can be seen only by comparing distant eras. This kind of stillness can be reassuring. It suggests a place where nothing demands attention, where nothing changes suddenly. Even when something does change, it does so in a way that is gentle enough to feel like a long exhale. Out here, the idea of temperature becomes abstract too. In the inner solar system, warmth is a daily experience. Close to the sun, the concept of heat and glare is easy to imagine. Far from the sun, the cold is not an immediate sensation in our telling. It is simply a condition, a background reality that shapes materials. It makes water ice hard. It makes nitrogen and methane behave in new ways, freezing and flowing in slow cycles. It makes atmospheres thin or temporary. It makes sunlight feel precious, a faint energy that still matters. There is also a calmness in how the solar system sorts materials by distance. Close to the sun, light elements and volatile ices are less stable. farther out, those materials can survive. This sorting is part of why the inner planets are rocky and the outer worlds are rich in gas and ice. The early solar system was a place where heat and cold created zones, and those zones influenced what could form and remain. Over time, the zones persisted as a gentle gradient, and the planets took their places within it. Even now, as the sun continues its long life, that gradient remains. The inner worlds are warmed, the outer worlds are cooled. The in-between regions hold mixed stories, and beyond the last major planets, the gradient becomes so faint that it blends into the galaxy's background. If you're still awake, that's perfectly all right. You can let blending be a soothing theme again. Everything eases into everything else. The heliosphere itself is an example of easing. Its boundary is not a sharp edge. It is a region where the sun's outward flow becomes less dominant and the interstellar medium becomes more present. The interstellar medium carries its own particles and fields, shaped by the broader environment of the galaxy. The meeting between the two is not dramatic. It is a quiet shift in balance, a slow change in the texture of space that can be sensed by instruments, measured patiently, understood gradually. And beyond that, the galaxy continues, vast and calm, with its own rhythms. Stars orbit the galaxy's center. Gas clouds drift and swirl. Dust lanes curve through spiral arms. None of this is quick. The galaxy is slow. Its changes are large and gradual. It is an environment that encourages the mind to slow down as well. You might find it comforting, in this outer region, to picture the solar system as a set of nested shells. Not literal shells, but layers of influence and objects. The innermost layer is the sun itself, bright and active. Then come the rocky planets close in, each with its own face of stone, cloud, or ocean. Then the belt of fragments, scattered and open. Then the gas giants, large and dominant, with moons that are worlds in their own right. Then the ice giants, subtler and cool-toned. Then the Kuiper belt, a wide ring of distant travellers. Then the fading reach of the solar wind, and then the interstellar medium, the larger context into which everything gently blends. You can picture these shells as concentric circles fading into the dark, each one softer than the last. The image is not a diagram. It is a mood, a bright center, a slow outward drift, a quiet edge. And when the mind holds that mood, sleep can come naturally, not as something forced, but as something allowed. In the quiet, you may also notice how soothing it can be to think about scale, without turning it into a list of measurements. The planets are large, yet they are small compared to the space between them. The sun is enormous, yet it is one star among many. The heliosphere is vast, yet it is a small bubble in the galaxy. Each scale contains the next, and the mind can move between them, like moving between near and far in a soft focus photograph. The nearness of a crater rim on Mercury, the farness of Neptune's blue, the faint shimmer of a ring plane, the subtle glow of a distant frost plain, the steady light of the sun as a point, the even steadier glow of countless stars beyond. All of it exists together, layered, calm. If you find yourself returning to one image, you can let it be a gentle resting place. Perhaps Saturn's rings, still circling, still catching thin sunlight. Perhaps the moon's pale face near Earth, with its familiar craters and soft shadows. Perhaps Mars, wide and open, with a quiet horizon. Perhaps Jupiter's slow, striped cloud tops, turning under faint starlight. Perhaps Neptune, deep blue in the far dark, with Triton gliding by. Perhaps Pluto, a small world with a bright plain and long shadows. Or perhaps the simplest image of all, a bright point of sunlight behind us, a field of steady stars ahead, and the feeling of drifting, unhurried, through an immense, calm space where nothing is urgent, and where everything continues in its gentle, repeating motion. And the feeling of drifting can stay with you, even as the details begin to thin and soften. The sun remains behind us as a bright point, steady and patient, a small lantern in a wide night. The stars ahead remain calm and unmoving, each one a distant light with its own quiet life. Between them, space holds its gentle emptiness, not a void that threatens, but a spaciousness that allows everything to move without haste. If you're still awake, that's perfectly all right. You've done nothing wrong by staying awake. Nothing here expects you to arrive anywhere. You can simply remain on this slow cruise, letting your attention rest wherever it wants to rest. It can be comforting to return, one last time, to the ordered path we followed outward. The sun's bright surface and steady outflow. Mercury's cratered stone under sharp light. Venus's calm veil of cloud. Earth, brief and distant, a blue-white sphere with a pale moon circling close. Mars, rust-toned and spacious, the wide openness of the asteroid belt, Jupiter's broad bands and patient storms, Saturn's rings circling endlessly in delicate arcs, Uranus, pale and tilted, with faint rings like thin lines drawn around it, Neptune, deep blue in dim light, with Triton gliding quietly by, the Kuiper belt, with small icy travellers moving in long loops, and Pluto among them, a real world with frost and shadow. All of those places are still there. They are still turning. They are still orbiting. They are still repeating their quiet motions. The solar system has not changed because we travelled through it in imagination. It continues, steady and reliable, whether it is watched or not. And now, at the far edge of the sun's immediate influence, the story becomes a gentle blending. The sun's outward breath grows thin. The interstellar presence grows slightly more noticeable. The boundary between them is not a line, but a soft region where one quiet environment eases into another. Nothing snaps, nothing closes. Everything simply fades and blends, like light dimming gradually at the end of a long evening. You can let that blending happen in your own thoughts as well. You can let the names fade first. You can let the images blur next. You can let the sense of direction soften until there is only a calm feeling of space and slow motion, of steady light and gentle darkness. If you're still awake, that's perfectly all right. You can allow your thoughts to become less specific. You can let them drift like tiny, slow-moving points, circling and returning without effort. You might keep one simple picture, if you like. A distant sun behind you, a quiet field of stars ahead, and the idea of orbits everywhere, invisible circles traced through dark, each one steady, each one repeating, each one patient. Or you might keep an even simpler picture. Just the sense of gentle travel, unhurried, with nothing to solve, nothing to do, nothing to hold. The solar system is full of motion that feels like rest. Rings circling a planet in countless small repetitions. Moons gliding along their paths with calm regularity. Planets turning, bringing day into night and night into day without any urgency. distant icy worlds looping slowly through faint light, returning on timescales so long they feel like the deep rhythm of the universe itself. And beyond them, the wider galaxy continues in the same spirit. Stars orbit the center of the Milky Way. Gas and dust drift in slow patterns through spiral arms. The night sky is not hurried, it is steady, and its steadiness can be shared. If you're still awake, that's perfectly all right. You can let the steadiness do the work. You can let the words become less important than the quiet mood they carry. In the end, our cruise does not need a sharp finish, because space itself does not offer sharp endings. It offers gradual distance. It offers fading light. It offers repetition that continues long after any single journey is done. So we can simply remain here, drifting at the outer quiet, with the sun a small beacon, with the stars calm and unwavering, with the solar system behind us still turning and circling in its gentle order. And as your attention softens, you can let the details thin away like mist, until there is only the feeling of a slow, steady night, and the comfort of knowing that nothing is urgent, nothing is required, and everything continues quietly, calmly, and patiently.